Then we discussed the geometric factor for induction logging. So I introduced you the radial geometric factor, which is the response of a thin cylindrical shell having infinite height. So as the radius of the cylinder increases, how its response varies. So we found that we get a peak very close to the borehole axis at a distance of just half of the spacing. So if you want to eliminate the borehole effect, contributions from mud and from mud cake, then we should shift this peak towards uh, right. Similarly, I introduced you about the vertical geometric factor, which is the response of a thin disk of infinite extent. So as the disk is moving, then its response varies like this. So again, here is the tool, and the response is flattened for a certain interval, and then it tapers off. So if you want to minimize the solder bed effects, A and C are solder bed effects. They are also contributing. If we want to minimize their contribution, then we should have we should somehow taper it here and here. And this we learned that this thing can be done. The depth of investigation and vertical resolution, they can be controlled by adding the auxiliary coils. Right? So a commercial induction resistive tool has got a number of coils. Some are primary coils, some are auxiliary coils. Then we discussed the sonic log. So first I introduced you about compressional and shear waves. How do they travel through a medium, and while they travel, the medium particles they vibrate about their mean positions. In case of compressional wave, the particles vibrate in a direction parallel to the direction of propagation. Whereas in shear wave, the particle motion is perpendicular to the direction of propagation. And I also told you that P waves can travel through both solids as well as fluids. However, the shear waves can travel only through solids. These waves cannot travel through fluids. And in general, the compressional wave velocity is greater than the shear wave velocity. The shear wave causes some sort of deformation of the medium. Right? The shape of the medium is also disturbed, changed for a while. Now, uh, in this slide, I told you how P and S waves are generated with a source in the borehole, and they are reflected after striking the boundary interface between borehole and formation. The refracted rays, after refraction, the waves bend. So in this case, they bend away from the normal in accordance with the Snell's rule. So as angle of incidence increases, angle of reflection also increases. So for a particular angle of incidence, the angle of refractions become 90 degree. so that the reflected waves they travel along the interface. Such waves are called the head waves. Right? They are traveling along the interface, along the borehole wall, and they are traveling with formation velocity. And they are also returning back into the borehole. So they are useful for us because as they are returning back into the borehole, we are able to record them by putting a receiver in the borehole, right? And since they are traveling through formation in the formation with formation velocity in which we are interested. So again, they are useful
পরে
for
খাবো
us. Right? These waves are also trailing through the formation and with formation velocity. But we cannot record them because they are going away from the borehole. We cannot keep our receiver somewhere here. There is no way. The receiver can be kept within the borehole only. So we don't have any means to record such waves. On the other hand, the head waves can be recorded because back into the borehole, as we see in this slide. So after reflection, after critical reflection, they are now coming back into the borehole. Here, the wavefronts are also shown. Then I discussed the measurement. So we, for discussion purpose, we had a simple configuration having one transmitter and two receivers. Right. So these are our compressional head waves, and these are compressional shear waves. Right. These are the wavefronts corresponding to different arrivals, different waves.
হ্যালো
Right. So we are
হ্যালো
sending sound pulses
हाँ वो
with the help
तो
of
वीडियो भेज
transmitter
भेज रहे
at regular intervals. Right? And for a given transmitted pulse,
हाँ ट्राई करो और बोल रहा
we
था
are getting wave train
नागा राजू सर ने
at
बोला
the
था ना कि
receivers.
वो कुछ सेलिमेंट्री बेसिन
So
का कुछ
this
नोट्स
wave
शेयर
train is
करेंगे
consisting of compressional,
उसके अलावा किसी और प्रोफेसर ने बोला था क्या
shear, pseudo relay, mud arrivals only. All arrivals are present here.
हम्म
But the first arrival is the compressional wave because it is fastest. So what we do
नहीं
with
नहीं अगर
conventional, we have been
मैंने सर को
doing
एक बार बोला था तो
conventional
सर
in
ने मेरे
conventional
को कॉल करने
measurement.
बोला इसलिए
We
इसलिए पूछ
just
रहा
detect
हूँ
the
और नोट्स था एक
first
दूसरा
arrival.
उस दिन सर ने बोला था कि सर करने का लेकिन अभी तक
Hmm.
नहीं किया
The timing is noted when the first
नहीं
arrival
किया ना
reaches the near
किसी
receiver.
और सर ने
And
कौन सा
again, the timing is noted when the first arrival reaches the
कौन कौन
farthest.
सर ने बोला था कि
Then we
वो
subtract.
नोट सर करेंगे जैसे कि नागाराजू सर ने सर बोला था
After subtraction, we get
सर में
this travel time, which we divided by distance
सेडिमेंट्री बेसिन का बोला
to
था ना
get the transit time. Right. So it was very simple principle, simple measurement. Here I told you if the tool is tilted or borehole size is
हाँ
varying, then we compensate for this
भेजेंगे बोले थे
by putting one more transmitter at the bottom.
क्या बोले थे एक्जैक्टली बताओ
So the average of these two cancels the error and we get the transit time. Then transit time is converted in terms of porosity with the help of this equation. So this is our recorded transit
अच्छा
time,
कौन कौन बोले थे
and the other
पीएचडी से
parameters they are standard. They have standard values.
अच्छा अच्छा
Their values are different
ठीक
for different lithologies.
अच्छा तो फिर कौन कौन सा रह गया यूएसडी सर का रह गया वो इंटरप्रिटेशन वाला जो पीपीटी
So
है
we
और
can see that higher the porosity, higher will be the transit time,
हम्म
and vice versa. I told you about cycle skipping. Cycle skipping takes place when the
सेडिमेंट्री बेसिन में बोले थे
first
ना
uh,
ठीक है, तो वो यही यूएसडी
arrival
बोलेंगे, यूएसडी सर का और वो सेडिमेंट्री बेसिस।
has got attenuated and it is not able to trigger the receiver. The receiver is triggered by subsequent arrival, next arrival, right? So,
ठीक है।
skipping introduces abnormal increase in transit time, which may be indicative of
नहीं नहीं,
presence
झूठ
of
मत
gas
बोलना
and
भाई,
fractures.
क्योंकि बीच में थोड़ा सा दिक्कत हो जाएगा वरना। बोले थे ना सर देने का।
Then we were discussing
अच्छा
the
ठीक है।
density law. Density is based on emission of gamma rays and interaction of emitted gamma rays with electrons present in the formation. Right. So the tool basically senses is governed by electron
ठीक है
density
सर।
of the formation, and electron density is approximately proportional to bulk density, which we are interested. Bulk density is related with porosity by simple relation. So we can convert the recorded bulk density in terms of porosity. So this is provided by the log, and the other parameters rho m and rho f, they have the standard values. So here I told you how density is measured. We have a padded tool where source and two detectors, the source and two detectors are mounted. The pad is pressed against the formation with a backup arm so that there is to eliminate the effect of the borehole mud. But mud cake is still present. So to compensate for effect of the mud cake, we use this chart, which is
यूएसडी सर का तो वो जो भी
derived from laboratory
रिकॉर्डिंग होगा वो
measurements,
सारा रिकॉर्ड
and
होगा
it
तो
is stored in computer memory. So with our count rates at the two detectors, we enter this chart
हाँ।
somewhere. We get this point, and then we move along this rib to get the actual value of rho v. This is called a spine
यस
rib plot.
क्या पढ़ा है
So
तुम?
this is
मैंने
some
कहा
sort
किया
of spine, and these curves they look like ribs. So it is a called a spine rib plot. Then we discussed photoelectric absorption coefficient, which is also recorded with the density tool, along with the bulk density. That is important to know. Both bulk density and photoelectric absorption coefficient both are recorded together by the same tool, by the same source and the same set of detectors. The only difference is for photoelectric absorption coefficient, we take a window corresponding to low energy. Right? So here we make the measurements in this window to
गुड मॉर्निंग सर। सर मैं प्रीतम बोल
find
रहा हूँ
out the
सर फ्राइडे से
photoelectric
क्लास है
absorption coefficient.
सर, आपने
Right?
कॉल करके बोलो।
So first, the tool records absorption index U,
हेलो सर।
and with the help of U and rho v, we deduce PE, that is photoelectric absorption
हेलो सर।
coefficient. Right? So this is
सर मैं सर गुड मॉर्निंग सर। सर
rho
मैं प्रीतम
v
बोल रहा हूँ सर,
and
फ्राइडे
U,
से मेरा क्लास है
both
सर,
are
आपने कॉल करके
available,
बोलो।
both are recorded. So PE is computed and plotted. P is very useful to differentiate among the reservoir rocks. We can say whether it is sandstone or limestone or dolomite with the help of PE, because it has distinct values for these three lithologies. Here we converted rho B into porosity. We did an exercise. We suppose that rho B is 2.4. Then corresponding to different three lithologies, we are getting porosity 15.2, 18.1, and 25. 0.1%. So it shows the importance of knowing the lithology before converting rho V into porosity. So based on this lesson, charts have been made. We can make use of these charts also directly. So for 2.4 rho V, we get three different values of porosity. Now, by the time, I think by this time, most of the students have joined us. Is it so? Hello.
Yes,
Yes,
sir.
sir.
How many are you there?
So we are 37 people.
Very good. So now I was just summarizing what we discussed during previous 2 days. And now I am starting with neutron tool, neutron law. Right? We are already familiar with the neutron porosity law. Now we will see its physical principle and its the tool design and how measurement is made. The neutron porosity tool bombards the formation with fast neutrons. So here we are sending fast neutrons, high energy neutrons into the formation. So this is the neutron tool, neutron porosity tool inside the borehole. You can see it is being pressed by a strong spring against the borehole wall. So it is decentralized. It is touching the borehole side. So here we have a source for neutrons. It is americium beryllium. So this source is bombarding the formation with high energy neutrons. And neutrons are, after reaching the formation, the neutrons are being slowed. Neutrons are colliding with other nuclei present in the formation. Right? Neutrons are colliding. There are collisions of neutrons. इधर ही है थोड़ी देर। 10 मिनट हाँ 5 मिनट बाद हाँ हाँ 10 पानी की का बात है हाँ ठीक So the neutrons are colliding with other nuclei present in the formation. We have number of elements present in the formation. For example, calcium, silicon, carbon, etc. Fluids are also present. So hydrogen elements are also there. Right? So neutrons, there are collisions of neutrons with the nuclei of elements, different elements present in the formation. So here the interaction is between neutrons and the formation nuclei, right? In case of density tool, we had interaction between gamma rays and the electrons, right? So when neutrons are colliding with other nuclei, they are getting slowed down. Their velocity is reducing. The neutrons are slowed down to thermal energy level by collisions with formation nuclei. Hydrogen having same mass as neutron is most effective in slowing down the neutrons. So this thing should remember. There are many other elements also. Collisions are taken place with all the nuclei, but hydrogen nuclei, they are most effective in slowing down the neutrons. So the tool response is basically governed by the amount of by the number of hydrogen elements. And since hydrogen is mostly present in the pore fluids, response of the neutron tool reflects the porosity. You understand this? Hydrogen elements are mostly present in pore fluids. They are present in water and hydrocarbons. So the response of the tool reflects the formation porosity. This is the principle, physical principle, right? So the tool measurement is based, our measurement is based on this principle. Right? So after slowing down and after getting slowed down to thermal energy level, the neutrons are reaching the detectors and being counted there, right? Neutron log is generally plotted assuming limestone matrix. So before that, neutron tool is calibrated to give porosity directly. We have already seen number of log examples having neutron log, and if you remember, the neutron log is plotted directly in terms of porosity. Right? The porosity scale increases from right to left. Neutron log is generally plotted assuming limestone matrix. So the log gives correct porosity against clean limestone. This is another thing to be remembered. We will discuss it uh, in detail. In case of lithology other than limestone, neutron porosity requires some correction, which is 4.5 for sandstone and -7 for dolomite.
I hope everybody is the end of this online
If
training
there is low porosity, it means
Good afternoon.
less
My name is Uttam
hydrogen,
Kundu and
lesser
I
number
am
of
currently
hydrogen
pursuing
elements,
university
lesser
in
hydrogen
Department of
atoms,
Applied Geophysics, IITSM Dhanbad.
and
Firstly, I
count
will
rates
like to
will be
thank.
higher
Firstly, I
because
will like to express my heartfelt gratitude
more and more
to Sri
neutrons
Vishal
will be
Sastry
able
sir,
to reach the
President of SPG
detectors.
India, for providing
On the
us
other hand, if
this
we have
invaluable
high
learning
porosity,
opportunity. I also want to thank Dr. NP Singh sir, BCG
means
training coordinator and former general manager of
if we have
OPG,
high porosity,
for organizing
it means we
this
have higher
online
concentration
training
of
program.
hydrogen atoms
I will also like to thank Dr. Sanjeev
and
Kumar Pal sir, AG
lesser
and
and
Anil
lesser
Kumar Chaudhary sir, Planning and
electrons.
Investment in Charge, Department
So
of Applied
lesser and
Geophysics,
lesser
IISM Dhanbad,
neutrons will be able to reach the
and
detector. So
faculties from
count
other
rate will be
universities
low.
for their efforts in making this program a success. This 2 week log program has
We
been
use
very
two
informative,
detectors
covering
for
various
borehole
topics in
compensation.
seismic, oil log, and
Is this
aspects of the oil
clear
and
to you?
gas industry. I
Hello?
would now like to share some thoughts
Yes, sir.
from myself
Yes,
and
sir.
my
Yes, sir.
fellow batchmates regarding this
Okay,
online
very good.
training.
If
I
porosity is
believe
high,
the
it
lessons we
means we have
introduced in our last semester
more
provide a
higher
more than
concentration of
adequate level to
hydrogen
learn various
atoms.
new concepts of
There
electrical
will be
application
there are the
while implementing
collisions
research.
are taking place, neutrons are being slowed down, and if hydrogen atoms are great in number, then the neutrons will be slowed down rapidly, lesser and lesser neutrons will be
Okay,
able
so
to
slide
reach the
data
detectors.
machines,
So count rates will
interpretation,
be low.
visibility analysis,
Low
refractory
count rate
prediction,
means
reservoir estimation, hydrogen trial
more
burden indicator are totally
H2
new concepts to us, but their
and high
ability
porosity.
to
On the other
transform
hand,
huge
high
fields
count
thanks to
rate
the excellent teachings of the
corresponds to low
faculties of
porosity.
this study program. Their teachings will benefit us as
Okay,
we are about to study these topics in our
so
upcoming semesters. The session on the
for a
application
given
of
depth,
data analytics,
we
artificial
have
intelligence
count
began
rate
again.
at the near detector.
The
We have the
test
count
field
rate
was
at the far
technical
detector.
interest
So
for most of us,
we have two count rates. What we
as AI,
do,
ML, and data analytics are hot
we
topics
take the
nowadays,
ratio
and their application in
n-
oil and gas,
count
renewable
rate of the
technologies,
near detector divided by count rate of the far detector. Near detector count rate divided by far detector count rate. So with this ratio, we enter this chart.
apart from the core geophysical topics.
You
Just
remember
like
in case of
economics,
density also
oil
we
and
were
gas, and sedimentary
entering a
basin was
chart
covered. This
here.
study program even ends with 3 days
Short
long
spacing
session
detector,
on
long
data
spacing
analysis,
detector.
prediction, and analysis of petrophysical properties, which was
With
covered
the
by
help of with readings of these two detectors, we enter this chart. This axis is short spacing detector count rate, long spacing detector count rate. So we we got some point here, and with the help of this point and with the help of this chart, we found the correct value of rho b. So similar is the case for neutron tool. With neutron tool also, we are getting two count rates at the two detectors, and then with help of these count rates, we are entering this chart. Actually, it is the ratio. Hmm. Near detector count rate to far detector
all the
count
topics
rate
were covered
ratio.
in the
It is a ratio.
detailed and interactive manner.
Suppose at a particular depth, the
Interactive manner.
value
I
of
would like to
this
suggest
ratio is
you
2.
all the faculties
It means
and then
the near detector rate is double that of the far
yes.
detector. Right?
At the end,
So at a given
I
depth,
will like to request. At the end, I
we
will
are
like to
here.
request
We enter
uh,
this chart from
President
here,
of this.
draw a
Like
straight
to
line,
make a
right?
request. I will like
And
to
then
make a request to
find out the corresponding porosities. The x-axis is the porosity.
like to make
This top line,
request.
top curve is for dolomite. The middle one is for limestone.
I will like
The
to make
lowest
a
is
request
for
to the President of
sandstone.
SPG India, Sri
And
Vishal
again,
Sastry sir,
these charts, this
to
chart,
kindly
they this has been
to
prepared
kindly
by
provide
laboratory measurements on
us with the PDF
core
copy of
samples
the
for
presentation to all the
dolomite,
faculty of
limestone, and
ONGC
sandstone.
for the
Right.
benefits of the PG students.
So corresponding to a ratio of 2, we are getting different
For the
values of
benefit of
porosity for the
PG
for
students,
three
I request
different
the participant
lithologies.
of this online training
For
makes the
sandstone,
most
the
of it.
value is close to 20%. For limestone, the value is 30%. And the porosity is 8.5%. So the same ratio is leading to different porosities depending on the lithology. Now, as we have mentioned in the previous slide, Newton log is generally plotted assuming limestone matrix, assuming that the lithology is limestone. It means we have given instruction to the computer to make use of this limestone curve to get the porosity. So accordingly, the computer for this value of ratio, the computer enters this chart and gives a gives this value 15.5. The computer plots this value at that depth 15.5. I hope you understand. A near to far detector ratio of 2 corresponds to about 20% porosity for sandstone, 15.5% for limestone,
And
and 8.5% for
on the
dolomite.
behalf of our batch, I will
Right?
like to make a request to President of SPG India, Sri Vishal Sastry sir,
So again, this
to
has been
kindly
emphasized here.
provide us
As
with
per
the
international
PDF copy of the
practice,
presentation
Newton
of
porosity
all
log
the
is
faculty
plotted for
pages
limestone
for the benefits
matrix,
of PG students.
irrespective of actual
Benefits
lithology.
of PG students.
This is the
I hope every
international practice.
participant of this online training program makes the most of it.
As a result,
Thank you.
neutron log porosity value is to be corrected for actual lithology in case neutron log alone is used for porosity estimation. So this thing will be clear by seeing this example here. So we have a part of the log. Actually, it is the same log which we saw in our first slide. We have a caliper here, then gamma ray, ST, and on this track, I have neutron porosity curve, this pink one, and this is the density curve. So both the logs are recorded together and they are plotted together. They have been plotted in the same track, right? So against sandstone, we are getting a crossover. Across sandstone, we are getting crossover. Neutron is crossing over the density. Now, density scale is 1.7 to 2.7. Okay. Whereas neutron porosity scale is 0 to 60%. This means porosity is increasing from right to left. Here we have 0 porosity, here we have 60% porosity. Zero point 0.6 means 60%. Okay. Now let's read neutron porosity in for this sandstone. So it is this one. How much is the value? One division is equal to 6 porosity units. So we have 0 here, 6, 12, 18, 24. So it is around 24%, slightly less than 24%. But remember, this value of 24% is valid only for limestone. Had this lithology been limestone, then this value would have been correct. But now we have sandstone. We don't have limestone. We have sandstone. So this value which we are reading from the log is not accurate. It needs some correction. It needs some correction. How much is that?
4.5, sir.
4.5. In case of lithology other than limestone, neutron porosity requires some correction, which is 4.5 for sandstone and -7 for dolomite. Because we have sandstone in that example, so we have to add 4.5 to the value we are reading from the log. So how much is the actual porosity here? About after correction, how much is the porosity after correction? Again, from the log we are reading, it is let us say about 23%. 24 is here, it is slightly less, so about 23%. And we have to apply correction of 4.5. How much it is?
27.5, sir.
27.5. So actual porosity will be 27.5. If you are using only, suppose you have only neutron log, if you don't have density log, you have only neutron log, then this is how you have to find out the porosity. If density log is available, then of course it becomes easier. As I uh, told you in the beginning, what we do, we simply read the value for the midpoint. So midpoint is somewhere here, right? So without bothering about any lithology or any correction, you simply read this value. How much is it? 1, 2, 3, 4, 24 we are getting here. So how much will be this value? 24 plus 3, about 27. So we are getting more or less the same value, but this we can do only if both the logs are available. If only neutron log is available, density is not available, then you don't know where is the midpoint. Okay. So in that case, you have to read the value shown by the neutron log and apply correction to it. Correct? Is it clear or not? Hello?
Yes, sir.
Is it clear to everybody? Hello?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, fine. So here, this is another example. For this sandstone, uh, the log value is 18. We have three divisions. 1, 2, 3. 3 in 6 are 18. So log reading is 18, and we are applying a correction of 4.5 to get the actual porosity, 22.5, right? If we use the midpoints, then how much we are getting, you can check. 1, 2, 3, 4, right? So 18 plus uh, you have to add about 4 porosity units more. Uh, So midpoint, this is at 24, sorry, 18, this is 18, and your middle points are somewhere here. Okay. So again, you are getting the same value. But in case you don't have density, you have only neutron log, then this is how you have to do. Fine. So let me proceed to the next slide. Now we have come to a very important junction. Density neutron combination. We have discussed both density and neutron logs. And now we will be discussing both of them together.
Day
Right.
3.
Density weights neutron.
কি ডে 3 কি ডে 3 কি বললি?
So I'm not joking.
হ্যাঁ শুনতে পাচ্ছিস?
This is the fact.
ডে 3 কি বলছিস? হ্যাঁ না ডে পরে ওই আইএমএল ছিল।
With this slide onwards, density and neutron
দাঁড়াও, বলছি।
will not be strangers. They
মার্জিন
have
ডেটা গ্রোথ
been wedded together. So let us
মার্জিন ডেটা
try
প্রসেসিং
to see, let us attend their wedding and how their wedding has will be useful to us.
अभी बिस्कुट मैंने दिया
ओके कोई बात नहीं
चिप्स दे दो चिप्स चिप्स
ठीक है
এ
চিপস দে তো बाद में बिस्कुट दे
हाँ।
दो
বোকা
आने
আমি
का
যাকে
ওকে।
ফোন করছি বোকা যদি যেই খাই আসে অফিসে ফোন করছি মাল পর হয়ে বসে আছে
So I think all of you are very eager to attend the wedding of Mr.
यार वीडियो
Newton
तैयारी
and
कर ली
Miss
तो
Density. Are you
ডে ওয়ানটা ওরকম ভাবে করেছি আচ্ছা
Yes, sir.
মারিন নিয়ে কিছু বলেন
good?
Yes, sir.
Fine.
হ্যাঁ মারিন ডেটা প্রসেসিং এর
Density and neutron logs, when plotted together in proper compatible scales, are very useful for
ইউজ মিক্স অফ
identification
ক্লাস
of
নিয়েছিল
lithology and gas and
ইউজ মিক্স
estimation of
ক্লাস নিয়েছিল
porosity. So, when
আরে সেই যে
plotted
আইএসএমএস নিয়ে
together
একটা ইউজ
in
মিক্সরা
proper compatible scales,
ও ক্লাস
this
নিয়েছিল
is I underline this thing. When plotted together, ये प्लॉट तो ठीक है एक साथ कर रहे हैं, वो कोई बड़ी बात नहीं है, बट बड़ी चीज है कि इन प्रॉपर कंपेटेबल स्किल्स,
আমি ভাবলাম
in proper compatible scales, that is important.
হুম
We cannot plot them in arbitrary scales. The scales we are choosing should be compatible. So let us see what
হুম
do we mean by this compatibility.
হুম আচ্ছা
By compatibility, what
যেটা
do we mean? The two logs are made compatible generally for limestone.
ভাই আর কাউকে পাচ্ছি না কাকে বলবো আর সবাইকে ট্রাই করে নিয়েছি পিয়াংসুকে বলেছিলাম পিয়াংসু
We make them compatible assuming that the lithology is limestone. We make them compatible for limestone.
যেটা ইউএসটি পার্টনার নিয়েছিলাম
How? By matching zero
জানেন যে
porosity
কালকে রাতে একটা ফোন
of
করে বললো যে ভাই এখন আমি
neutron log
কালকে
scale
সকালে পাঠিয়ে
with 2.7 gram per cc value of the density.
নবীনের পার্টটা করে দিয়েছে
You remember
নবীন যে
the matrix density for limestone is 2.7 gram per
করে
cc.
দিয়েছে।
Yesterday
হ্যাঁ
I talked about it.
নবীন হ্যাঁ ভাই নবীনের ভাই করেছে ভাই নবীনের ভরসা ছিল
The matrix
আরেকটা
density
করে দে ভাই তিনটা বলেছি
for limestone is 2.71. Actually, it is 2.71,
আরে ঠিক
but
আছে
for
আমার
simplicity, we are taking it as 2.70. And then I explained to you what we mean by the matrix density.
দেখ
So, matrix density means the density of a sample having zero porosity. There should be no pores present in the sample. Everything should be solid, rock matrix. Then the density measured will be the matrix density. So these values, they correspond to zero porosity, and we are calling them matrix density values. So I again repeat, 2.7 gram per cc density. It is the maximum the limestone can have. It is the maximum density. I can also define matrix density as the maximum density a lithology can have.
ঠিক আছে
A limestone can have
তুই
maximum density 2.71, not more than that. Because it is maximum because there are no pores available. There are no pores present. Everything is solid. Fine.
কোথায় হবে?
So can you have a value greater than this? No.
হাইট আছে কার?
Similarly,
কার ফ্লাইট
this
আছে?
is the maximum value
কি কার ফ্লাইট আছে?
of porosity a dolomite can have,
আমি শুনলাম ফ্লাইট আছে। আমার
2.87.
মাথা যাচ্ছে কি ফ্লাইট যাবে?
So these values they
আচ্ছা ঠিক
correspond
আছে
to
না,
zero
তারপরে লিখে
porosity,
বলবো না।
no pore volume,
ঠিক আছে।
no pores, everything solid. So theory- they are basically theoretical values. Some pores will always be there, but this is by we can extrapolate actually. We can say that if no pores are there, the density will be 2.7 for limestone, right? So coming back, zero porosity matches with
বলি তোর
matrix density,
তুই যে
which
ভিডিওগুলো
is
শেয়ার করেছিলি সেখানে
2.7 gram per
এইচ এর
cc
লেকচার
for
কি ছিল?
limestone. We are making the two logs compatible for limestone,
আচ্ছা আর ডে
right?
নাইনের
They are being wedded together for limestone.
ওগুলো ডে টেনের তো ওরা ওই লোকের ফার্স্ট ক্লাস ছিল তো
So
নাইনের
we are matching their endpoints. This is one endpoint, zero porosity
আরে
corresponding to
ডে
matrix
কি
density
ফটো তুলছিস
2.7. तो जो
ও আচ্ছা
न्यूट्रॉन पोरोसिटी का स्केल है
বুঝিনি
उसकी जीरो
ডে
डेंसिटी के
নাইন तो इया ছিল
स्केल में
ডিসিপিলিটি সেসিবিলিটি
2.7 से
ইন্টিগ্রেশন
मैच
আর
करनी चाहिए.
ডাটা ইন্টারপ্রিটেশন ম্যাপ জেনারেশন ডিএইচ এগুলো ছিল
For example, here this is our density scale. We can see here the scale is increasing from 1.7 to 2.7. So here we have 2.7. For neutron porosity, we have
তো তুই
zero.
এখান থেকে ঘুরবি কখন
The scale is starting with zero. So we
আর
have
একটা জিনিস
matched
ফটো বুঝতে পারবি
zero with 2.7 to
ডে
make them
ডে
compatible,
ওই ডে
right?
মানে এর আগের দিনটা
But अभी तो सिर्फ एक गांठ मारी है दोनों.
ডে আমি বলছি
तो
ডে নাইনে তো বললো
एक
না
गांठ काफी नहीं है हमारे लिए, दो गांठें जरूरी है.
আজ
तो
আজকে
दूसरी गांठ
আজকে
है
তো
ये.
ডে ইলেভেন তো
This is the second tie.
তোর হচ্ছে
100% porosity
ডে
should
এইট হ্যাঁ
100%
ডে
porosity
এইটে
should
মনে তোর সেশন
match
হয়েছিল না
with 1 gram per cc.
সেডিমেন্টারি বেসিনটা কবে হয়েছিল
Why? What is the logic behind it?
মোস্ট অফ এইটই মানে
Why
Sir,
100?
100%
সেশন টু
Yes.
porosity means the
ওটা লিখতে
rock
পারবি
is fully saturated with water. So, and the density of water
প্রিয়াঙ্ক
is 1
বললো
gram per
লেকচার
cc.
ওয়ানটা
Yes,
পড়বি
very
ফিজিক্স চ্যাপ্টার ওয়ান
wonderful. You are correct. 100%
এখনো
porosity
কমপ্লিট
means
করে নি
we don't have any rock. We have just water, and the water density is 1. So 100%, a value of 100
নম্বর
on porosity scale should match with 1
মোটামুটি
on the
পরের দিকে
density
মোটামুটি
scale.
খারাপ দেখবে একটু
Correct? So unfortunately, we don't have a space to
কারণ আমি
extend this
আমাদের
scale
দেখতে পাই
up to 100. We have limited to only 60. But if
না ভাই
you can do at your home, you can extend the scale till it reaches 100. And similarly, this you extend it till it reaches 1. You will find that 1 will match with 100. Okay. So these are the two ties between density and
জাস্ট একটা
neutron,
প্যারাগ্রাফ লিখতে হবে
and now they are
একটা
they
প্যারাগ্রাফ লিখতে
wedded
মানে তোকে
with one another. Right?
জাস্ট টপিকগুলো মেনশন করবি কি কি পড়েছে
these two ties they implies that 1 gram per cc is equivalent to 6 porosity units. That is a change of zero point 0.1 in density. A change of zero point 0.1 in density will
ধর
lead to a
সাড়ে
change
দশটায়
of
বেরিয়ে
6
গেছো
porosity units. So this
5:10
this you can check
হ্যাঁ
how
আমি
much
লিখে
is
দিয়েছি
one division
অর্পণের
value
স্যার
of
করা
one
আছে
division for density. One division
আমি দাঁড়াতে আমি বিরাট
is
করছি
equal to how many gram per cc?
হুম ঠিক আছে
This is density
শুরু
scale
করো তাহলে
1.7 to 2.7. The span is 1. 2.7 minus 1.7 is 1. And there are 10 divisions. So 1 divided by 10, that is zero point 0.1, is the value of one division. And what is the value of one division for porosity? For porosity, we have our span is 60 in terms of percentage. 60 divided by 10 is
So
6.
6.
So zero point 0.1 is matching with 6. And that's what we have written here. Zero point 0.1 gram per cc is equivalent to 6 porosity units. So if we increase the density of a limestone
হ্যালো
sample by this
ব্যস্ত
amount,
আছো কি
its porosity will
কারণ হচ্ছে আমি একটু ব্যস্ত পড়বো
change by this amount.
বলছি তো
This is what it
ওই
implies.
ওএমজিসি যে ট্রেনিং পেজ যদি তার ডে 8 এর যে সেকেন্ড লেকচারটা ছিল সম্ভবত মনে হয়
So
সেডিমেন্টারি বেসিন উপরে ছিল
marriage is
ওই
over.
লেকচারটা আমি তোকে পাঠিয়ে দেবো ওই
The
লেকচারটা মানে
density
একটু
and
স্কিপ
Newton
করে
now
করে
they are
দেখবি
wife
যে
and
ওটার মধ্যে
husbands.
স্যার কি কি টপিক পড়েছেন
Okay.
দিয়ে সেটাকে একটু মানে একটা প্যারাগ্রাফের মধ্যে লিখতে হবে যে স্যার
They have been made
টপিকগুলো পড়েছেন
compatible. If they are wife and husband,
আমি তোকে পাঠিয়ে দেবো
then they should not differ. And
আরে না সন্ধ্যার মধ্যে
this
যাই
is what
দুপুরের মধ্যে
we
না সেখানে বলছি
can check
দুপুরের
from
মধ্যে
the
বিকালের
logs.
মধ্যে বেরো
We have a limestone interval here.
বিকালের মধ্যে
This is the limestone lithology. And what we
এ হ্যাঁ
find,
একবার
both
ফোন লাগবে
density and Newton, they are
একবার ফোন
matching
লাগবে
one another. There is no separation.
ও আচ্ছা না আগের দিন নাম লিখে রেখেছি
They are overlapping one
আচ্ছা
one another.
আচ্ছা ঠিক আছে না তাহলে তোকে আমি পাঠিয়ে রাখবো তুই বিকালবেলায় এসে পর দেখবি তাহলে
Now either you read the density or you read the
ঠিক আছে
Newton, you will get the same value, same porosity value,
আইডিয়া
because
বলতে পারো মেনলি তোর
both are
আমি তোকে
matching.
ইয়া পাঠিয়ে দেবো মানে কিরকম আমি লিখতে হবে তো
This
সেখান
is
থেকে লিখে
another
মোটামুটি
limestone
কি কি
interval.
টপিকগুলো স্যার কভার করেছে মেনলি সেটাই ম্যাচ করতে হবে
Now against this interval, again you can check the two curves are
সব লেকচারগুলো হয়নি
overlapping one
বাকিগুলো
another,
হয়তো খানিকটা মিস আছে যেমন ডে 9টা প্রবলেম করছে
right?
তো ডে 9টা তো ওই লোকে গেছে ফার্স্ট ডে 9 হ্যাঁ ওই লোকে গেছে ফার্স্ট
Another limestone. Again, they are
না সত্যজিৎকে ফোন
matching.
করেছিলাম সত্যজিৎ বললো
There
তোর কাছে
are
নেই
some
ওটা
separations
ও
here
টোটাল 3
and
দিনে 4
there.
দিনে রেকর্ড করেছে
This is
তোর
because
সাথে
of
কথা
presence
বলতে
of clay minerals. We don't have a
ডে
clean
9টার জন্য একটু
limestone
প্রবলেম
here.
হচ্ছে কারণ এই লাস্ট 3 দিনেরটারও লিখতে
You,
হবে লাস্ট
you
3
can
দিনেরটা
see
পরে আমি
from
লিখবো
gamma ray
কারণ
log,
ডে 9টা
gamma ray
লেকচারটা নেই
logs are
ওটা
higher,
নবীন রেকর্ড করেছিল ওটা
so
ডিলিট হয়ে গেছে
the limestone is getting shelly,
ও মনে হয়
and
ওটা
that
এক্সপোর্ট করতে
separation is
ভুলে
because of
সামথিং কি
shelliness.
সামাও
Otherwise,
ডিলিট
the
হয়ে যাবে
two
খুঁজে
curves are
পাচ্ছি
matching, right?
ঠিক আছে
The density log
হ্যাঁ
itself
বলছো
can now
শনিবার
be
যাবে কি
treated as a porosity log for limestone
মানে কালকে
matrix with the same scale
না
as that
কালকে
of Newton
কালকে
porosity log. So immediately
কালকে এখানেও বলছি
we are
21
getting
তারিখে তো এক্সটেনশন
advantages.
আসবে না তাহলে 21 তারিখে তো রুমগুলো একটু বেশি ভিড় হবে তাহলে যদি 20 তারিখে যদি যাই
After
তাহলে
the
আমরা
two
মোটামুটি
logs
সবাই
have
এক
been
কাছে
made
রুম নিতে পারবো
compatible, they have
আর
been wedded
21 তারিখে
together,
আমার
right? They are now more beneficial to us. This is one of the advantage. Now density log can be treated as a density porosity
সবাই কি 21 তারিখে যাচ্ছে দেবে
with the same scale as that of the
যা
neutron.
21 তারিখে কি সব কিছু একটা অনুষ্ঠান আছে নাকি কিছু একটা আছে মনে হয়, সেটার জন্য নাকি বাস টাস চলবে নাকি
Suppose you want to convert density into porosity, then you have to use this relation which we have studied. This is how we convert. This is our log value 2.2.
জানি কিছু একটা আছে বলছিল বাবা
This has been done for this interval. So if I read this value, it is coming to be 2.2 gram per cc using this scale 1.7 to 2.7, right? So 2.2, it is coming to be 2.2, right?
তোকে তো তাহলে বিষ্ণুপুর দিতে হবে
So now I am converting it in terms of porosity, and because the lithology is limestone, so rho Ma is 2.71, and after simplifying I am getting a value 29.8
সৌভিক তো তোর একবার
or
ডায়রিয়া আইসেন
30. I am getting a value of 30
তো দেরাদুন আছে
for the porosity derived from density.
হ্যাঁ
There is a
নবীন দেরাদুন
subscript D. D stands for density, and there is another subscript L,
নবীনের একটু
which
টুকটাক কাজ
which
আছে,
indicates
নবীনের
that we
কাজ
have
ওর কাছে খানিকটা একটু পড়ে পড়ে আছে।
the lithology
তো আর সৌভিকের
limestone.
হচ্ছে যে সৌভিকে বললো যে আর মাঝখানে মানে আমরা
Thank
তো
you.
টোটাল 4 দিন মাঝখানে ঘরে থাকতে পারছি, তা সৌভিক বললো আমার তো যাওয়া আসে একদিন চলে যাবে, একদিন মানে যাওয়াতে একদিন আসাতে একদিন, তোরা 4 দিন থাকতে বললো আমার সেই দুদিনের মতো পাচ্ছি, আর একবারে
So what value we are getting? It is 30%.
ক্লাস করবো না
This is after doing this mathematical calculation.
21 তারিখ সকালবেলায়
Now what you do,
ধন্যবাদ
you read the value of density log directly using this scale 0 to 60, which we have been doing so far.
আর ও খবর নিবি না যে বাসার ব্যাপারটা কি
हम तो पहले से ही कर रहे हैं, मगर क्यों आपने किसी ने मुझसे ये नहीं पूछा, ये तो आप डेंसिटी लॉग है, इसकी यूनिट तो ग्राम पर सीसी है, और आप हमें इसको रीड करने के लिए बोल रहे हैं और कह रहे हैं कि ये डेंसिटी पोरोसिटी इतनी है, तो ये कैसे है? तो अब आपकी समझ में आ गया होगा कि ये इस तरह से है. नाउ डेंसिटी लॉग इटसेल्फ कैन बी ट्रीटेड एज ए पोरोसिटी लॉग, करेक्ट?
तब बाहाते तब नहीं तब
तो अभी डायरेक्टली हम रीड करते हैं लॉग से. यहाँ हमने कैलकुलेशन की,
ना तो बेसिक गाइडेर মধ্যে আছে
ये वैल्यू मिली.
জিনিসপত্র তো
Let us see what we get after reading it directly from the log. So here we have 0, 6, 12, 18, 24, 30. So about the same value we are getting
ডাইরেক্ট অনুবাদ না পেয়ে একটা অটো বলে নিলি
from the log directly.
জিনিসপত্রগুলো একবার নিয়ে তুই একবার
Now we are not doing any calculation. We are simply reading the value.
আর জিনিসপত্রগুলো একবার শিফট করে দিতে হবে গিয়ে পর রুমটা
So
নিয়ে তো আরেকটা
this is one advantage. We can treat the density log as porosity log.
আচ্ছা এখন যদি জিনিসপত্রগুলো বিদা করবি তার জন্য সকালবেলা
We can read the porosity values directly without doing any calculation. Is it clear to everybody?
দেখতে হবে 21 তারিখ বাসের উপর
Yes, sir.
Very good.
সেটা কিছু থাকবে তো আশা করি
Density and Newton logs plotted in limestone compatible scales superimpose one another against water-bearing clean limestone.
সোমেশ
The difference between the two is nil. They superimpose one another. They match
অরিজিৎ
one another. So we have already seen it.
আর সোমেশ
They are matching,
তো কই রোড়াই চলে গেছে
right? So they after their marriage they become one.
হ্যাঁ আবু তো নিয়ে নিছে
They don't have any difference of opinion. Right.
দুটো রুমটা দুটো আলাদা পোরশন আছে মানে ডায়মন্ডের গোটা ভাই রুম
Now we come to the next point.
একটু বড় বড়
The two curves, however, show separation,
মাঝখানে একটা পার্টিশন
and actual lithology is other than the clean limestone.
খোলা দরজা মানে দরজা
The
পুরা
two curves
দরজা
show
চলে আসে
separation when
যে
actual
সিঙ্গেল ঢুকে
lithology is
ভিতরে আর
other than
কেউ
clean
বসে আছে
limestone.
হ্যাঁ
This is obvious. If we
আমি
have
যে
made them
যাচ্ছি
compatible
ওর
for
নাম
limestone.
প্রতীকদার রুমটা মনে হয় বলছিল আমাদের যেতে রোহনদার প্রতীকদার যেতে মনে হয়
If
ওই রুমটা
actual lithology is not limestone, suppose it is
আমাদের মনে হয়
sandstone,
নিচে রুম নিচে
then
ওইরকম মনে হয়
the
একদম
two curves will
কনের
not
সামনের দিকে যে
match.
কনের
They
ঘর
will show
রুমগুলো
some
ওই রুমগুলো তো
separation. And this we can see
যাইনি ভাই তুই যে
in the
বলছিস
example.
নিচতলায় আশা করি না আবু তো নিচতলাই তো আছে
The two curves, however, show separation when actual lithology is other than clean
আশা করি তাই হবে
limestone
কারণ ম্যাক্সিমাম শাড়ি আশা করি নিচে
or
থাকবে
when gas or light
কারণ
hydrocarbons
নিচে
are
আমার
present.
ম্যাক্সিমাম যে সিঙ্গেল রুমগুলো
Okay.
রয়েছে সেরকম আমার নিচের তলাতে রয়েছে
I move to the next slide to
ম্যাক্সিমাম
show
সিঙ্গেল
you
রুমগুলো যে নিচের তলায় থাকে তাহলে
to
অত বেশি শাড়ি আর
illustrate
কিছু
you
হয়
this point. Here again we have
ডায়মন্ডে
limestone.
কি পিএইচডি
This
থাকছে
is a limestone reservoir, correct?
যদি পিএইচডি
And
থাকে
we
পিএইচডি
have
সিঙ্গেল বলতে পারে
density and neutron logs. Density is in
ভাই তো
blue,
তার রইল ইয়াদের
neutron is in pink, and both are plotted in
মানে
compatible
সামনের মধ্যে আমার ডায়মন্ড
limestone compatible scales, as is the standard
সবাই
practice.
সবার আশা কম
Invariably, you will find the two logs plotted in compatible scales. That is the practice actually.
আরে না যদি তোর
So
ধর
uh,
26 থেকে যে হেরিটেজ
let's
প্রোটোকল পড়ে চলছে
come to this
সেটা যদি
interval
25
here,
থেকেই তোর যদি
which
মেনটেন
is a
করে
clean
তাহলে
limestone
আমি
interval.
বলবো
Gamma ray counts are very
যেটা
low. It
তোরা
means
আমাদের
it
এখানে
is
দিতে পারবি
clean. Now, what is happening here?
আমার মনে হচ্ছে পরে বছর
There is a lot of separation between density and neutron. आप कहेंगे कि आपने तो बोला था
আরেকটা কি পজিশন আছে দুটো পজিশন
लाइमस्टोन होने से दोनों मैच करेंगे, सेपरेशन नहीं होगा दोनों में, मगर यहाँ पर तो बहुत बड़ा सेपरेशन है।
ডিবিজিসির আসবে নাই
ये सेपरेशन किस लिए आ गया? ये आ गया गैस के आने से, दोनों के बीच में गैस आ गई,
আচ্ছা আচ্ছা
तो उस वजह से
ঠিক আছে না অনেক
दोनों सेपरेट
হয়ে
हो
গেল
गए. तो दिस सेपरेशन is
হ্যাঁ বাসের
among
বাসের
this separation between these two curves
ঠিক
is
আছে
indication of presence of gas. Right? तो लाइमस्टोन में भी दोनों सेपरेशन दिखा रहे हैं, डिफरेंस दिखा रहे हैं, एंड द कॉज ऑफ दिस सेपरेशन इज गैस. तो अभी आपको याद होगा कि गैस को आइडेंटिफाई करते हैं हम इस तरह के कैरेक्टर से, वेयर वी हैव ए वेरी लार्ज क्रॉसओवर. ये तो हम पहले से देख रहे हैं, तो अभी आपको और ज़्यादा क्लियर हो जाएगा ये कि व्हेन देयर इज सेपरेशन बिटवीन डेंसिटी एंड न्यूट्रॉन लॉग्स, न्यूट्रॉन रीडिंग abnormally low, density reading abnormally high, then that is indication of the gas. आँख आप आँख बंद करके कह सकते हैं गैस है. Okay. Now coming here, this is again limestone, but here the two curves are more or less matching. तो ये क्या हो गया यहाँ पर, कैसे मैच कर रहे हैं? यहाँ पर तो इतना सेपरेशन दिखा रहे थे, यहाँ पर मैच कर रहे हैं क्योंकि यहाँ पर गैस नहीं है. यहाँ पर वी हैव ओनली ऑयल, लाइट only oil. We don't have light hydrocarbon gas here. We have oil here. So against the oil or against water, they will be matching. Actually, water होने से perfect matching होगी. Oil होने से भी you can see there is some separation. This is also oil. Okay. Match is there. So at the bottom we have shell. So this entire interval is hydrocarbon bearing. We have top, we have gas at the top and oil below. So there is a gas oil contact somewhere here, right? So if I perforate this interval, then it will produce gas. Generally, we don't do so. Hmm. It is because it is a gas cap, so we keep it because it is useful for maintaining the pressure of the reservoir. What we produce is oil, right? So coming back, this we were discussing density and neutron logs plot in limestone compatible scale superimpose one another against water bearing clean sandstone. Against water bearing clean limestone. However, the two curves will separate when actual lithology is other than clean limestone or when gas is present. So when gas is present, they are showing separation. This I have shown to you. Now let us see if lithology is other than limestone, what happens. So come to this part. This is the case of the sandstone reservoir. We have this sandstone and this one another sandstone. This lower sandstone, this is water bearing as we can see from resistivity. Correct? So this is a clean water bearing sandstone. Now coming to density and neutron logs, what you find? You are seeing a separation. The two curves separate when actual lithology is other than plain limestone. So when actual lithology is sandstone, we have separation. And we call this separation as crossover. Right? So this is the normal character of density and neutron logs against the sandstone. If you have sandstone, then you get such a crossover, which is useful to identify the porous permeable zones. We have been doing actually since last 2 days, we have been doing it. But now we are throwing more light on this. Okay. Now for clean limestone, the density neutron separation or crossover is +7 to +8 porosity units. How much is the separation? One division is 6 porosity units. So it is about 8 porosity units here. This separation, this crossover is about 8 porosity units. It means the density porosity is about 8 porosity units higher than neutron porosity. Okay. And for dolomite, this separation is in reverse direction because there is a negative sign. Value is 14 to 16 pu. I will show you dolomite example also in later slide. And for shale, the separation may be as high as -45 porosity units. तो शेल तो हमारे पास में ही है, शेल का तो हम तुरंत देख सकते हैं. This is the shale, and you see the separation between the two curves here. Now neutron is reading higher than density. So there is a negative sign here. Basically, we have taken it as density porosity minus neutron porosity. So because for shale, neutron porosity is high, density porosity is low, so we are getting a negative sign here. So how many divisions we can count? One, 2, 3, 4, 5, 6, 7. 7 6 are 42. So the difference is about minus 42 porosity units. Very close to this value, minus 45. Okay. Now we come to next point. Against coal, both density and neutron loss show abnormally high pseudo porosity. Coal character we had seen yesterday. Hmm. I am showing you again here. Do we have coal somewhere? Yes. This is a coal layer. And another coal layer also. This is coal layer. Hello.
Yes, sir.
Yes, sir.
So this is a thin coal layer. We have low gamma ray counts here. And what about density and neutrons? Both are moving towards left, towards high porosity. Our porosity scale is increasing from right to left, 0 to 60. So they are going, both are going beyond 60. That's why what we have written here. Both show abnormally high pseudo porosity. So if both of them are moving together towards left, towards high porosity, they are going beyond the scale. Values will be more than 60 actually. They have crossed 60 value already, right? So this is a very useful character to identify the coal beds. And resistivity is also higher. Resistivity, there is some increase in the resistivity also. So this point is covered. Against gas-bearing clean formations, neutron log shows abnormally low porosity. Now, um, I think let's have a short break. अभी ये 5-10 मिनट्स के बाद मिलते हैं. ओके.
Okay.
Yes, sir.
ओके.
Hello, dear students. MP Singh, your coordinator for the training. Good morning to all of you.
Good morning, sir.
Good morning. Who all are there? I can see. Uh, Today is the last day. So, how you find the training? I mean, do you think that this last 2 weeks has been fruitful for you people?
Yes, sir.
Yes. Okay. So all of the students, just let us know okay, how was our performance and how much marks would you give to us for this training and its content and its knowledge sharing. So just write 10, 20, 30, 80. That will represent your percentage of marks you wish to give us for this training for 2 weeks. In the chat box, you can write just percentage 10, 20, 30, 40, whatever you feel like. I can see Ankit Kumar, yes sir. Kajal Saini, yes sir. Shruti Tiwari, 95. 99, okay, good. Then Asha, let me read it again. Shruti Tiwari, 95. Muhammad Ala, 98. Then बहुत marks हैं. I think we should pat our back. Then Pritam, 97. Kajal, 80. Good. Nishu, 97. Rahul, 97. So there is a lot of scope for improvement. Jyoti says 90. Rachna Maurya says 99. Okay. Suraj says 90. Good. I think हम लोग पास हो गए. इसका मतलब we should celebrate. Shraddha Pathak says 95. Okay, good. I think our performance has been good. Shruti Tiwari says definitely. It's okay. And Kajal Sani, yes, when you are benefited with the training. Ashok sir, I think has joined. Hai? Good. So back to Ashok sir.
हाँ डॉक्टर साहब.
Please continue.
Okay. हाँ डॉक्टर साहब ठीक पूरा दिख रहा है ना?
हाँ, it is full screen and it's loud and clear both.
Okay. Hello students. Hello. Hello.
Hello,
Yes,
sir.
sir.
Okay. Well, actually, I have to check whether link is there or not. So, should we start now?
Yes, Ashok sir, you can start.
Okay. So, do you understand the compatibility? How the two logs have been made compatible? Hello. Hello.
Class representative, please respond.
Yes, sir.
Are you clear about what we have discussed so far? Or
Yes, sir.
you have any question?
Yes, sir, I have a question.
Yeah, please.
Sir, I just wanted to discuss what all will be the trends in these logs in case of overpressure.
In case of overpressure, actually, uh, yes, that is quite important. But I don't have any example of that right now with me. I will try to speak about it later on, because now we have to discuss many things and we have short time. So can we postpone it? Can we
Yes, sir,
postpone
sure.
it? Okay, okay, okay. Any other question regarding what we have discussed so far? Okay, if you don't have any question, I have a question, and I hope you will reply it. Suppose I want to make the two curves, density and Newton, compatible for sandstone. Then what should I do? How the two logs can be made compatible for sandstone?
So then we need to calibrate 0% porosity with 2.65 gram per cc for sandstone.
Very good, very good. It means you have understood it. So
Yes,
now
sir.
let's proceed further now. Against gas-bearing clean formations, Newton log shows abnormally low porosity. एक्चुअली ये तो हमने देख लिया कि गैस के होने से we are getting a large separation, large crossover. Whether the lithology is limestone or sandstone, irrespective of the lithology, we are getting a large crossover in case the gas is present. But what is the reason? The cause of such a large separation? What is that? That we have not discussed so far. So here is the answer. The against gas-bearing formations, Newton log shows abnormally low porosity due to lower H2 index. The Newton shows abnormally low porosity due to lower hydrogen index. You know, we have a low hydrogen concentration when gas is present, and as compared to oil and water. In gas, the hydrogen concentration of hydrogen atoms is less, is generally less than that against oil and water, right? And if you remember, the neutron tool response is basically governed by hydrogen concentration, correct? As we discussed today in the beginning. So if gas is present, uh, then hydrogen index, hydrogen concentration will be lower. And Newton will see it as something having very low porosity. And that's why the Newton shifts towards low porosity. The neutron is basically governed by hydrogen concentration. And if hydrogen concentration is low, the neutron sees it as if the porosity is very low. So that's the reason neutrons in the presence of gas, the neutron shifts towards low porosity, that is towards right. I think it's clear.
Yes, sir.
Whereas density law gives high porosity due to lower bulk density. The density, bulk density basically, if gas is present, the bulk density will reduce because gas is very light as compared to oil and water. The presence of gas will reduce the bulk density. Reduction in bulk density means increase in the porosity. So density will shift towards high porosity, that is towards left in case gas is present. Right? As a result, this is shifting towards right, this is shifting towards left. As a result, the two saw a quite large separation, a large crossover. The density neutron separation may be as high as 45 porosity units against a gas stream. We can see as high as 45. Depends on the gas saturation actually. Larger the higher the gas saturation, larger will be the separation. So how much is the separation here? Maximum separation is about 1, 2, 3, 4. 4, 6 are 24. About 24 porosity units separation is there. What what about this? This is sandstone and this is also gas bearing. Neutron moving towards right, density moving towards left, causing a large separation. And let's see how much is the separation. So 1, 2, 3, 4, 5, 6, 7, 7.5. Let us say 8. 8, 6 are 48. So 45, 48. Because here the gas saturation is very high. Therefore, we are getting a separation close to this value, 45 positive. And the sign is positive. Sign is positive because the density porosity is greater, neutron porosity is lower. Neutron porosity is very low. Our zero is here. This value is very low and this value is very high. Sign is positive. Okay. Let us discuss this example in slightly more detail. So at the bottom we have coal layer. It is indicated by density and neutron logs, gamma ray, resistivity. Then this is the sandstone. And this sandstone is partly water bearing and partly oil bearing. You see the bottom of the sandstone is here. So near the bottom resistivity is low, about 2 ohm meter. But above this depth resistivity starts increasing and it becomes as high as 20, 30, 40, 50, 60, 60, 70 ohm meter. It reaches a value of about 60, 70 ohm meter. So clearly this is oil. Okay. So we have oil water contact somewhere here. At this depth we have a oil water contact. At if it is a single sandstone, then the water will lie near the bottom and the hydrocarbons will lie towards the top because water is heavier. So it will settle down near the bottom and hydrocarbons will float above the water. Okay. Then we have a shale layer. This is shale because gamma ray counts are quite high here. This is again sandstone, somewhat shaly sandstone, right? Then again there is a shale layer, and now we have sandstone. This is sandstone, and here the crossover has started increasing. In water bearing portion, it was only this much, and now it has increased to this value. And as we move up, the crossover or separation is still higher. It means this above this depth, we are getting gas. So this is the gas, which is clearly demarcated by density and neutron, by large separation. Okay. Then top of the sand is somewhere here, right? We can see from SP, the top is somewhere here. It is evident from density neutron also. So at the top we have shale. Here also we have crossover, but it is not as large as it was here. Then what do you say? Resistivity is still higher and it is at the top also. So what do you say? It is oil or gas?
जब 3 बजे आऊंगा
हाँ, ठीक. Certainly it is hydrocarbon because resistivity is high. And I will say that it is gas. It is also gas, even though the separation is lower, but it will be gas because it is the same sandstone unit, and this is the top of the sandstone. So in the same sand unit, it is highly improbable that we will have oil at the top or water at the top. If we have gas here, then this is also gas. Then question arises why separation has become smaller here if it is gas. The answer is presence of clay minerals. This top part is not as clean as the bottom. The bottom part was very clean. The concentration of clay minerals here was very low. And as we are moving up, the saliness is increasing. The clay minerals concentration is increasing. Right? And it is the presence of clay minerals which are bringing the two curves again closer. Right? Separation has decreased because of presence of clay minerals. Otherwise, as far as the fluid is concerned, it is still gas here. Now, another thing I can mention is here this is a fining upward sequence, as we can see from gamma ray as well as from resistivity curve. It is a fining upward sequence. It means as we are moving up, the grains are getting finer and finer. The grains were coarser here and they are becoming finer and finer as we are moving up. So this is another example of a fining upward sequence. The advantage of this is we can infer the depositional environment with, with itself. Okay. So before coming to the next point, I again emphasize that we get some crossover against sandstone even if there is no gas. Here we don't have any gas. Here we have either water or oil, right? Okay. Clearly there is no gas here. We have gas only here. In spite of the absence of gas, we are getting this crossover. And this is quite normal to sandstone. The reason of getting this separation against sandstone is that these two curves, density and neutron, they have been made compatible for limestone and not for sandstone. So if limestone is not there, then they will show some separation. So this separation is coming because of this lithology being sandstone, not limestone. I think it's clear. Hello.
Yes, sir. Yes, sir.
Okay, fine. Now we come to the next point. Tight layers are indicated by lower porosity trend in both density and neutron loss. So I had shown you some examples of the tight layers previously. So again, let me see if we have a tight layer somewhere. Probably this is a thin tight layer, as we can see in resistivity log, MLL. MLL means microlateral log. So this one is having better vertical resolution. This is a thin layer showing very high resistivity. We are saying a tight layer because porosity is very low. It is highly resistive, and its high resistivity is due to poor porosity. On the density and neutron log, it is matching with this. So there is increase in the density against this layer, and the neutron is also moving in the same direction towards low porosity. So earlier also we had seen tight layer, and this is another example. So against tight layers, both neutron and density tend to show lower porosity. They tend to show lower porosity. They move towards low porosity. Okay. So now coming to next point. The next point is about the estimation of porosity. Okay. Actually, if the porosity is limestone, then there is no problem. For example, here, suppose you want to find out what is the porosity at this depth. Can you please tell me what is porosity at this depth? Hello? Hello?
Yes, sir.
Okay, you are able to listen to me. I am asking what is the porosity at this depth? What is this value? This is limestone. Both the curves are matching here. So either you read Newton or you read density. It is one and the same thing. Please tell me the value quickly.
It's
Sir,
27%.
24,
27. Okay.
more than
20.
24.
Let's say 27. Very good. So if we have limestone as our lithology, it is very easy to read the porosity because the two curves are matching. But if sandstone is there, for example, here we have sandstone, then what is the porosity? What is the porosity of this interval? So for such interval where lithology is sandstone, we simply take average of the density and Newton porosities. We simply take the average of density and Newton porosities. आप इसमें डेंसिटी पोरोसिटी रीड कर लीजिए. It is about 35%. And now you read Newton porosity. It is about 28%. You take the average. It is coming out to be 31.5%. और एवरेज से लेने से भी ईजियर क्या है कि आप इन दोनों के बीच की वैल्यू रीड कर लीजिए जो हम अभी तक कर रहे थे. ओके, यू सिंपली रीड द मिड वैल्यू. It is about 30 and slightly more than this. So 31.5. तो मिडिल में रीड करने के लिए भी you will be getting the same value as you get by taking the average. यहाँ पर दोनों कर्व्स क्यों मैच नहीं कर रहे हैं? Why the two curves are not matching here? एक 35 रीड कर रहा है, दूसरा 28 रीड कर रहा है. What is the reason? Hello.
Because these are calibrated on clean limestone basis, and we have lithology as sandstone. So that is
Very
what
good.
is not
Very
matching.
good. Very good. Yes. This is what I wanted to listen. We have made the two curves compatible for limestone and not for sandstone. Here our actual lithology is sandstone. So that's why the two curves are not matching. They are showing some separation. So this separation is coming out due to lithology being different than the limestone. And we use such a separation, crossover, to identify porous permeable sandstone layers. Right? We have been doing since beginning. Okay. Now, what about this interval where we have gas and this separation is very large? How to know the porosity of this interval? How to know porosity for this interval? So this is known by this equation. Phi d square plus phi nl square, then you take the square root and divide it by 2. So that gives you the porosity. So we have done it for this interval. So here density porosity, if you read, is about 46.5%. And the Newton porosity is only about 3%, half of the division, about 3%. So we apply this equation. solid, and then we get a value 33%. So this is how we can still estimate the porosity against gas bearing zones. This was the case for sandstone. We do we use the same relation for limestone as well. So this is the limestone example here. We have already discussed it. So now I want to know what is the porosity here in this interval. So I will read the density porosity, which is about 41, and Newton porosity, which is about 19. Apply this, put those values in this equation, simplify, and I will get a value about 32%. Okay. So we have seen that the density neutron combination is very useful. If we have both the logs, generally both logs are there. If we record density, then we record neutron also. It is very rare that only one log is available. Generally, both of them are available, and they are available in compatible scales. Right? So we can find out many things from density and neutrons. We can identify the lithology. We can estimate porosity. We can identify coal layers, and we can also identify gas bearing zones. We can identify tight layers. So many things can be found out with the help of density neutron combination, and it's very easy. Coming to the next slide here, we have a density neutron cross plot. This is the density neutron cross plot, and it is the offspring of density and neutron. This plot is an offspring of density and neutrons. What I mean to say is this: if you remember, this is the plot for density, right? And this is the plot for neutron. So if we combine these two plots, then we get this plot. If I give you these plots, then you yourself can draw this plot. So this is, so I call it an offspring of these two. So let's see what is there in this cross plot. On the x-axis, we have neutron porosity. On the x-axis, we have neutron porosity. And on the vertical axis, y-axis, we have the bulk density. Okay. So this plot has been prepared by using both density and neutron values. It's a combination of density and neutron. Here we have neutron porosity, here we have bulk density from density. And remember, density is increasing like this. We have 1.92, 2.1, 2.2, etc. What is this scale? What is this scale? This scale is again porosity. from density. I can say this is the density porosity. Density porosity. If we convert these values into porosity for limestone, then we get this. You can see corresponding to 2.7, we are getting about zero porosity. Okay, so let me repeat. What do we have on the x-axis? Please tell me what is on the x-axis. Hello.
A neutron
Neutron
porosity.
porosity.
Neutron porosity from Newton tool. What do we have here?
Bulk densities.
From density tool. Very good. And what about this?
Density porosity.
You said density porosity, na?
Yes, sir.
Yes, you are correct. So this is density porosity. Neutron porosity, density porosity. But remember, neutron porosity and density porosity, they are valid for limestone lithology. Okay? And you can see both are matching. This is the limestone line, which is a straight line. You take a value of 10 here, neutron porosity 10, and then move in this chart. You encounter limestone here. Now you move towards density porosity. You are again getting 10. So for limestone, both are matching. You take any value. Let's start from here. We have 30, neutron porosity 30. Let's go to the limestone line. And now let us see what is density porosity. Density porosity is also 30. So we are getting the same neutron porosity and density porosity for limestone. And it is because the two curves are overlapping one another against limestone. So whether we read neutron or density, both will give the same value. But this is not the case if lithology is sandstone. So in case of sandstone, let us say neutron porosity is 10. And now we move to the sandstone line. So we come somewhere here. Now we move to the density porosity. It is coming this much. How much? About 18%. About 18%. So they are not same. There is a difference. In earlier slide, we had seen there is a difference of about 7-8% porosity units. Where is that? Yes. For clean sandstone, the density neutron separation is about 7 to 8% porosity units. So whatever we have studied, we are getting same things in this cross plot, right? Now let us see how this cross plot is useful to us. Okay. we will use this cross plot to estimate the porosity and to identify the gas bearing zones. We are taking this log example here. Okay, we are selecting two depths, one this one, another this one. So first let us take this depth here, indicated by green arrow. So at this depth, what is our porosity? So we read the values of these two logs. Density porosity is 29 and neutron porosity is 32. We simply take the average. Average is coming out to be 30.5. Directly also we can read 1 division, 2 division, 3, 4, 5. So slightly more than 5. 5 into 6 is 30. So again 30% porosity. Now let's see what we will, how to get it with the help of this chart. So what we are doing now is we are using this chart to get the porosity at this depth. So for that we read the two values, density and neutron porosity values. One is 29, another is 32. Yes. So 32. This is the neutron porosity is 32. So we enter into this chart from this point. Here we have 32 and move upward. We draw a straight line upward. Then the density porosity is 29%. So we use this scale. This is density porosity. And our 29 is somewhere here. Okay. So we again draw a straight line passing through this point, horizontal line like this. The two lines are meeting at this point, which is very close to the limestone line. So it tells us that this corresponding depth, at this depth we have limestone as lithology. So we got idea about the lithology. Lithology is our lithology is limestone. Because this point is very close to limestone line, so lithology is limestone. Okay. Now how much is the porosity value? So to know the porosity value, we draw a normal from this point. We draw a normal to the limestone line, perpendicular. And we can see that here this line has got a porosity scale 0, 5, 10, 15. So let's read the actual porosity with the help of this scale. So 20, 25, 30. 30, one division is how much? 1 equal to 1. So we have 30.5 here. So we are getting the same value which we are getting after the calculation, right? So if we don't want to make any calculation, we can use this chart. The advantage of using this chart is you will get the idea about the lithology also, because this point is very closest to limestone line. So our lithology is limestone. So we are getting information about lithology as well as we are getting the porosity. Okay. Now coming to next depth. At this depth we can see we have a gas bearing zone. This is the crossover, large crossover we are getting. So it is indicative of gas And at this step, if we want to estimate the porosity, we use this equation. We have discussed it already. I think this square root is taken after dividing by 2. Okay. So we are getting a value 32% porosity here with the help of this formula, this equation, 32%. Now let's make use of the chart and see how much is the porosity. So we first read these values. The Newton porosity is 19%. So we enter the chart at this point where we have 19 and we draw a straight line. Okay. Now the Newton is reading 41%. Sorry, density porosity is 41%. So we enter from this point. Here we have 40, 41. Okay. So we enter the chart from this point, draw a straight line, horizontal straight line. The two lines are crossing here at this point. Okay. And if I extend this line further, I am getting a density, bulk density about 2.05, which is quite low. So if points are falling in this region, it means we have gas. If points are falling in this region, it means we have gas. So we know the type of fluid, it is gas. Now how in order to read the porosity, what we do, parallel to this line, we move parallel to this line. Okay. We draw a line parallel to this line. This is provided in this chart. So this is the parallel line. And now it is meeting the limestone at this point. Now read the porosity here, what it is. We have 30 here, 31, 32. So again, from the chart also we are getting a porosity 32, which we got after calculation. So this is how we make use of the density Newton cross plot, right? I hope it's clear. Any doubt? Hello.
No, sir.
Apart from lithology and porosity, this cross plot tells us, gives us indication about presence of some minerals also. For example, this point, this line, this is for anhydrite. Anhydrite is an evaporite having very low porosity. The porosity is almost nil, right? So anhydrite porosity is almost nil. And what is special about anhydrite? The special thing about anhydrite is it is quite heavy. You see, its density is very close to 3 gram per. So if anhydrite is present in some interval, then our points will fall here, somewhere here. Similarly, this is another element or some other lithology. The point is lying here. This is something else. Similarly, sulfur, salt, they are here. Salt is right. Salt is also an evaporite, just like anhydrite. And it is on the other extreme. It is very light. Sulfur is also very light. So that's why we are getting these points. And all these points, anhydride, salt and sulfur, they are close to zero porosity. They are close to zero porosity. Means they don't have any porosity. It means they can act as a good cap rock. So these evaporites, they are very good cap rocks. So here we have another example. We have used this chart for the case of sandstone. Procedure is the same as we have discussed earlier slide. So we move to the next slide here. Okay. Here what we have done is we have taken a carbonate example. Basically, we have a carbonate lithology here. Okay. This is carbonate, almost clean carbonate, right? And if you see the resistivity log, it is increase in the resistivity. So it is oil bearing. This part is oil bearing. On the other hand, this part is also limestone, but here the resistivity is falling. So we have water at the bottom. We have water at the bottom. Okay. So we have, this is oil, this is again oil. All these intervals are oil bearing. And at the top we have gas. We have a crossover here. So for limestone, if density and Newton are showing crossover, then blindly you can say gas is there. So this is limestone and we are getting a crossover. So without any doubt you can say it is gas. Had it been water or oil, then the two curves would merge, would overlap one another, as is the case here. Here they are more or less matching, but when gas is present, they are showing separation. So this is analogous to this example. So here again we had limestone and we have a gas cap here at the top. There is a crossover here. Okay, now after discussion of logs, what we do, our the primary objective of showing this slide is basically to summarize the estimation of porosity. We have taken this interval and we have estimated porosity by different means. Okay. So these are our density and Newton logs. This is sonic log. So we are making use of all the three logs to estimate the porosity. So first of all, we have used only the density log, only density to estimate porosity. So for that purpose, this is our density log. We will read what is the density value here. The average we have taken like this. What is this value? So if we read this value, we will be getting 2.23. So we put 2.23 here. And because lithology is limestone, so we use a value 2.7 for rho matrix. And rho f is 1. So after simplification, we are getting 28. So this is the porosity obtained from density log alone. Okay, 28%. Now we let us take the Newton log alone. Suppose density is not there, only Newton is there. So you have to find out porosity from Newton in that case. We have taken the average here. Newton is this. Newton is the red line. Yes, red line is the Newton. So let us see how much is the porosity here. We have a scale 0, 0 here, 1 division, 2 division, 3, 4. 4 6 ja 24. 24 plus 4, 28. So again we are getting 28% from Newton. Now we estimate the porosity with the help of sonic. So for sonic, the porosity equation is this. You remember this? This is the transit time, observed transit time. We can get it from this law. So how much it is? Scale is 40 to 140. So span is 100, and 100 divided by 10 is 10. So let's read this value. 40, 50, 60, 70, 80, 90, 100. So I am putting a value 100 here. 40, 100. Then delta T matrix for limestone is 47. So 100 minus 47 divided by 189 minus 47. And then because it is a shallow depth, only 1000, around 1000, the limestone here are unconsolidated. So I am using this part also. Here TSS is the transit time for nearby shale. So the nearby shale is this interval, right? So let us see what is transit time for this. So it is somewhere here. This was 100 and I don't know how I have taken 135. From where? Maybe from some other shale layer, which is not shown in this log. So TSH is 135, and after simplification, I am getting a value 27.6%, which is quite close to this. This is from Sonic. At last, what I have done is I have taken density neutron combination. So for density neutron combination, I have this relation. Porosity dn, that is porosity derived from density neutron combination. So either we can read the porosity directly, midpoint, or we can read these two porosities and take out their average. So this is 28, this is also 28 in this interval. So the average is also 28. So this is how porosity is estimated. This is, you can say, summary of different methods of porosity estimation, right? Now, in this slide, we have done the same thing for sandstone. Actually, we have already discussed it, but all those things have been summarized in this slide. Correct. So this is we are estimating porosity in this interval here. So first of all, we use the density log alone for porosity estimation. We read the value rho b. How much is rho b? So rho b is coming to be 2.25. So porosity value is 24.2%. Okay. Then I am taking neutron log alone. The neutron log value is 18%. And I have to add 4.5 because it is sandstone now. So again, I am getting value 22.5, which is slightly less than this. Not exactly same, but close to this. Now coming to sonic log, here we have, this is a good depth here. So we have consolidated sandstone, and accordingly I have this relation for sonic porosity. So I read the value T from the log. How much is this? How much is this value? 40, 50,
80, sir.
60, 70,
80, sir.
80, about 80. So I put 80 here, and value of TMA is 52 for sandstone, 189 for mud filtrate. So I'm getting a value 20.4%, which is still less. Finally, I am using the combination, density neutron combination. So one is 18, another is 27, average is 22.5. Okay. So this is how we can use different methods to estimate the porosity. And as we can see, there may be some differences, as we saw here. There may be many reasons for this, which we don't have time to discuss them here. But one thing is there, the density and neutron law is one of the simplest way to estimate the porosity, and it gives reliable porosity. Now, the basic concepts have been discussed, different tools, their physical principles have been discussed. So now we are in the next slides, we will be seeing logs, and we will be interpreting we will be doing the log interpretation. So, first of all, identification of lithology. How do we identify lithology? जितने लॉग्स हमको डिस्कस करने थे, जितने टूल्स डिस्कस करने थे, वो हम कर चुके हैं. अब हम इंटरप्रेशन पर आते हैं. एक्चुअली नहीं है कि हम अब तक इंटरप्रेशन नहीं कर रहे थे. हमको इंटरप्रेशन वी हैव बीन डूइंग इंटरप्रेशन, लॉग इंटरप्रेशन फ्रॉम द वेरी बिगिनिंग, फ्रॉम वेरी फर्स्ट स्लाइड. But now we will do it in detail. Okay. So first of all, how to identify lithology. Actually, we have already discussed in this log example, which is the same as the one shown in the first slide in the beginning. These are our lithologies. We have 3 sandstones, one at the top, another in the middle, and the third one at the bottom, near the bottom. Yes. And these are the shale beds. This is shale. Correct? You see there is a large difference between density and neutron. So this is shale. At the top also we have shale. This is also shale. And then we have shaly sand layers also. This is shaly sand. This is another shaly sand. This is another shaly sand. And this is also shaly sand. Right? The log characteristics have been summarized below. For sandstone, limestone, and dolomite, these are our reservoir rocks. These are corresponding lithologies. Here we have lower borehole size. We have seen we get development of mud cake because of invasion. So lower borehole size, low gamma ray counts. Gamma ray counts are low. The SP can be positive or negative. It can be both normal and reverse, depending on the salinity contrast between formation water and mud filtrate. In this given example, SP has not developed well. And the reason is here we have a poor contrast between formation water salinity and mud filtrate salinity. And that's why we did not get a good SP here. We have low value of neutron porosity, lower. This is our porosity increasing from right to left. So against shale, neutron is showing abnormally high porosity, whereas against reservoir rock, it is moving to right towards low porosity. So that's why I have an arrow downward. Similar is the case for density. For shale, density is higher. For reservoir rock, density, there is a drop in the density. There is a drop in the bulk density. So again, I have an arrow downward. Transit time, for transit time also, the arrow is downward because we can see there is a decrease in transit time across porous zones as compared to shale. Resistivity is upward. There, the resistivity of these rocks is generally higher than that of shale. So the arrow is upward. For shale, it is just reverse. Okay. So our lithology is reflected by all the logs. It is not that only gamma ray reflects lithology. Lithology is reflected in all the logs as we can see in this example. Fine. So I hope you won't have any problem now to identify the porous permeable zones. Next example is this. So here again we have uh, a sequence of shale and sandstone layers. At the top we have shale here. Caliper size is large. Gamma ray counts are high. We have a normal SP here and we have shale baseline here. So this is shale as per SP also. Resistivity is low and neutron log is moving towards left. Density is also moving toward left, but because this is probably because there is a large borehole size here. Otherwise, generally against the shale, if neutron moves towards right, density moves towards left. As we can see here, against the shale, neutron moving towards right and density moving towards left. So then at the bottom of the log, okay, here you can see neutron is moving towards right and density towards, sorry, neutron towards left, density towards right. एक इधर दूसरा उधर. Then this is the sandstone clearly shown by gamma SP. Okay. And here the two curves, density and neutron, they are very close to each other. So this is sandstone. Again we have shale here. Sandstone, shaly sand, right? Sandstone, shale, sandstone, shale, sandstone, shale, sandstone, and again shale. So whenever there is a sandstone, density and neutron are coming closer, kissing one another. On the other hand, whenever we have shale, the two curves are moving away from one another. Next slide. Here I have a gamma ray log here and I have density neutron logs on this track. Let's have a look at the scales. The density which is solid line the density, bulk density is having a scale 1.95 to 2.95. Earlier we had 1.7 to 2.7, but now it is 1.95 to 2.95. And the Newton porosity scale is minus 15 to 45. Earlier generally we had 0 to 60, but here we have minus 15 to 45. You can check that even though scales are different from those we had earlier, but these scales are again compatible with one another. The scale of one log has changed, so correspondingly the scale for another log has also changed. But they are meeting our conditions. What is that? 0 should match with 2.7 and 100 should match with 1. So those two conditions are being fulfilled here also. Okay. The purpose of showing this example is to show the behavior of density and neutron against different lithologies. So it's a sort of summary, and it's very important. So let's see how the density and neutron tools, neutron logs, they behave against different lithologies. So at the bottom we have shale here. Gamma ray counts are high, and neutron moving towards left, density on the right side. Hmm. So this is shale. There is no doubt to say that the lithology is shale. Above shale we have another lithology. If you have gamma ray log alone, then both these two lithologies appear as if the same lithology. Right? On the gamma ray, with the help of gamma ray, we cannot distinguish between these two lithologies because the gamma ray is same for both of them. Right? But the density and neutron are different. This is anhydrite. So for anhydrite, this is the neutron porosity and this is the density. As we have mentioned already, anhydrite is very heavy. Its density is very high. So it is going beyond 2.95. Right? Neutron has shifted from this to this value, that is towards lower porosity. Actually, if we know where is our zero, then we will see that this lies very close to zero. This curve, this value corresponds to zero porosity. I have minus 15 here, 45 here, so zero is somewhere here. So this neutron porosity against anhydrite is very close to zero. Okay. Now we move Next, we move further up. We get salt. For salt, the neutron porosity remains more or less same as for anhydride, but density has dropped drastically because salt is a light rock. Hello, are you listening to me?
Yes, sir.
Okay, fine. So we have salt here, and you see the salt has very low density. But again, the porosity is close to zero. So both anhydride and salt, both are evaporites, having almost nil porosity, and therefore they act as good cap rocks. We don't have much examples of these in India, but otherwise they are frequently encountered in other countries. We move up and we encountered a dolomite bed here. Here we note that gamma ray is very, very low against the evaporites. It is slightly more against dolomite, but not as high as against the shale, right? So for dolomite, this is how neutron and density are behaving. This is neutron on the left side, density on the right side. Okay. So the character is somewhat similar to that of shale. देखो शेल में भी थोड़ा मिलता जुलता पैटर्न है, यहाँ पर भी वही है. So sometimes it becomes difficult to say whether it is shale or dolomite, but it requires practice. With experience, we can differentiate dolomite from shale. So another thing to be noted, within dolomite, the two curves are moving towards high porosity as we are moving up towards high porosity. So porosity at the bottom is low, and as we are moving up, the porosity is increasing. How to estimate the porosity? If it is oil or water, then we can simply take the average as we have discussed in earlier slides, and that average will give us the porosity value for dolomite. Okay. Next is sandstone. So there is some decrease in gamma ray against sandstone, and against sandstone, you remember we are getting a crossover due to matrix effect. These two curves, they are made compatible for limestone, not for sandstone. So they are showing some crossover against sandstone. Okay. Now here again, as I am moving up, there is decrease in porosity. The porosity is decreasing. Okay. How to estimate porosity? If it is oil and water, we can simply take the average we can simply read the value for midpoints. That will be the porosity. Okay. So porosity here will be something like this, and here it will be somewhere here. Okay. After sandstone, we encounter limestone. Gamma ray is as low as against sandstone, and the two curves, density and neutron, are overlapping one another. They are matching. Correct? After limestone, we are encountering shale. So again, gamma ray is reading high, and neutron moving towards left, density towards right. So it provides a summary of all the lithologies. Now you can see why I have a negative sign here. My zero lies somewhere here. And scale is increasing in this direction. So if scale is increasing in this direction and I have a zero here, it means all these values are negative. And that's why this value is negative, minus 50. Though I will not be getting any value from the log in this negative range. All values encountered, observed, will be either 0 or greater than 0. This is close to 0. Okay. So I can say 0 is somewhere here. So values will be either 0 or greater than 0. I won't be getting any value which is negative. But still I have to put it minus 15 because this is 45. I am bound by the two conditions. 0 should match with 0 porosity should match with matrix density 2.7, 2.71, and 100% porosity should match with 1. So मैं इन दो गांठों से बंधा हुआ हूँ और आई शुड से डेंसिटी और न्यूट्रॉन इन दो बंधनों से बंधे हुए हैं. That's why if we have a scale 1.95 to 2.95 for density, we have to have a scale minus 15 to 45 for neutron porosity. Okay? Is it clear?
Yes, sir.
Good. This is another example where we have different lithologies. For example, this is sandstone here. We have a crossover here. This is shaly sand. So because of shaliness, density has moved towards right and neutron has moved towards left. So they are matching and there is no crossover. So it is the same character which we encountered against the limestone, if you remember. Against limestone also, the two curves match each other. In this example, we have limestone here. So you can see two curves are matching. And they are matching here even though it is not limestone. It is a shelly sand, right? So here they are matching because of presence of clay minerals. We can see the gamma ray counts are higher than here. So this is example of a shelly sand, and we should not mislead it as a limestone. तो आप देख रहे हैं कई चीज़ों का हमें ध्यान रखना पड़ेगा। अब मैं भी जो आपको एग्जाम्पल्स दिखाई थी उनमें एक ऐसी एग्जाम्पल थी यहाँ पर। हियर द टू कर्व्स were matching even though we don't have limestone here. So sometimes curves are matching but we have sandstone. That is because of shalyness. There is some matching here. So it means it is not a clean sandstone. It has got some amount of clay minerals. Strictly speaking, it is a shelly sandstone, not a clean sandstone. We have a clean sandstone here. This is the clean sandstone where we have a crossover, good crossover. And you see the gamma ray counts are here, gamma ray counts here are quite low. Another example of a clean sandstone is here, this one. Here also we are getting a crossover. This is the crossover, right? Here also gamma ray counts are very low. So now this is from India. Here we have a very tight, very, what should I call, Proterozoic. I think it is proterozoic. These are proterozoic sandstones here. Proterozoic rocks here. Very old. Somehow they have retained their character. They have not metamorphized. But they are very tight. Their porosity is close to zero. We have gamma ray logs. Then these are resistivity logs. Here we have neutron and density, right? This is neutron and this is density. This is photoelectric absorption coefficient, PE. PE increasing from 0 to 10. So here we have value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And delta T, sonic is also there with a scale 40 to 90. 40 to 90. It means one division is corresponding to 5 porosity units. Oh, sorry, 5 transit time. Now, I give you an exercise. Please try to identify lithologies in this example. Look all the logs carefully. We have gamma ray, SP, caliper is also there. Yes, this is caliper line, which is more or less a straight line. And these are the resistivity curves. These are neutron. This is neutron porosity. This is density. This is PE, and this is sonic. So look at these logs carefully and try to identify different lithologies. So you can start from bottom. So we can see that it seems to be a single lithology in this interval. So first try to find out what is the lithology, what is this lithology.
It's limestone, sir.
Exactly. Very good. This is limestone. Very easy because the two curves are matching. The two curves neutron density matching here. And it is further corroborated by other logs. What is the value? First of all, let us say what is the porosity here. The scale is again minus 15 to 45. Minus 15 to 45. And there are, again, one unit is corresponding to 6 porosity units. So if it is minus 15, then 6, 6, 12, 12 and 3, 15. So my 0 is here. My 0 scale of neutron porosity 0, sorry. The 0 in neutron porosity scale lies here. This is 0. Okay, if it is 0, then this is minus 3, minus 3, minus 6, and minus 15. So 0 is here. Now see the porosity of this limestone. How you have identified the porosity. Now tell me what is porosity. 0 lies
Is it
at the
around
point.
0?
It is very close to 0. It's very close to 0. So that's why I told you these are very old sediments. Very tight, highly tight. Hardly there is any porosity. Now for this limestone whose porosity is close to 0, what should be transit time value? Let's find out. We remember that for limestone the matrix transit time is 47 microsecond per foot. You remember? So this is the sonic log displaying the transit time. Let's see how much is this value. Our scale starts from 40. One division equal to 5, 45 and 50. So we
Is
have
less than 50.
yes, very close to 47. Somewhere it is just equal to 47. This is because the porosity is 0. So the transit time is showing the matrix value. Correct? So we have confirmed it with the help of sonic log that lithology here is limestone. Now we come to this curve. This is also showing a constant value throughout. This is PE. How much is this value? Let's see. We have 0 here. 1, 2, 3, 4, 5. Okay, 5. And if you remember, a value of 5 for P corresponds to calcite, that is limestone. So PE is also corroborating that the lithology is limestone. So we have limestone here in this interval. Everybody agrees?
Yes, sir.
Resistivity is abnormally high because porosity is very low. There are hardly any pores present in the rock. The scale, if you see, resistivity scale is 1 ohm meter to 1 lakh ohm meter. And here the values are saturating. That means our tool is not able to measure beyond this. The tool भी fail हो गया. It is giving a straight line here. These are so high values. Now we come up. We come across this interval, right? So from these logs, it is also a single unit. Let's try to know what it is. Here, neutron, this is density. They have separated, and their behavior is similar to that of शेल. शेल में ऐसा होता है ना, न्यूट्रॉन लेफ्ट में जाता है और डेंसिटी राइट में जाती है. So the character is similar to shell, but it's not shell because gamma ray counts are low. Then what it is?
আমি 3 দিনের লিখে নিলাম 2-3 ঘন্টার মধ্যে 3 দিনের পাগল লাগতো তো নাকি 4 ঘন্টা মোটামুটি 4 ঘন্টায় 3টা নবীন
Sir,
3টা লিখলো
dolomite.
লিখেছি মোটামুটি ওরকমই
Yes, it's dolomite.
আমি তোকে তাই তো বললাম স্কিপ করে করে দেখতে আমি তোকে
Now I can say that you are following what I am saying. I am too happy. So this is the dolomite. You see, this was the pattern, log character against dolomite.
যেমন ধর ওই লোকের ক্ষেত্রে একটা টপিক হচ্ছে লিথোলজি আইডেন্টিফিকেশন লিথোলজি আইডেন্টিফিকেশন মাঝখানেও অনেকগুলো
Let's confirm it from other logs also.
যেটা হচ্ছে যে ওই যে মানে তার মধ্যে যে মেইন টপিক
First,
লিথোলজি
take up
আইডেন্টিফিকেশন সেটাকে তোকে মেনশন
sonic.
করতে হবে এবার তার মাঝখানে যে তার মধ্যে আবার যে ছোট ছোট
Transit time is
যে topic গুলো
still
তোর
less
যদি
here.
মনে হয় যে মেনশন করা দরকার আছে তাহলে মেনশন করবি
How much it is? 40,
Sir, around 45 microseconds.
45, around 45. Around 45 microsecond per photon. And this value, this the value for matrix 43, we are getting around 45. So again, sonic is also matching. Sonic is from sonic also we say that this lithology is dolomite. Sonic is corroborating the density and neutron logs. Now coming to this curve, PE, photoelectric absorption coefficient. Uh, 0, 1, 2, 3, about 3.5. And if we remember, this value corresponds to dolomite. So PE is also corroborating these other logs. So now we have no doubt to say that this is dolomite. So we have limestone at the bottom, then we have dolomite. This is dolomite. And then above dolomite, there seems to be some unconformity because now we have some shales. The depositional environment has changed. This was marine depositional environment where limestone and dolomite got deposited. But now the deposition environment has changed. We have shales, sandstone, etc. So here sandstone means we are in a terrestrial or deltaic environment. Deltaic environment. Okay. Do we have sandstone in this example? Do we have sandstone example? Focus on this interval. Here gamma ray counts are low. See other logs in this interval. And tell me what lithology you think it is. There is increase in the resistivity. Okay. Neutron density. Density on the left side, neutron on the right side. There is crossover. Then PE is close to 2. PE is close to 2. 0, 1, 2. And transit time is how much? 40, 45, 50,
55 to 60.
55, 57, 55, 57 you can say. So now can you tell me what lithology you think it is? This time you are taking time.
For sandstone.
Yes, obviously it is sandstone. We have a density neutron crossover. Neutron towards right, density towards left. Transit time is close to matrix transit time for sandstone matrix 55. PE is close to 2. PE is 1.8 for quartz. Quartz means sandstone. We have low gamma ray counts, resistivity is higher. So all these point out that This is sandstone. This is sandstone. And there is some porosity here. There is some porosity here because our zero lies somewhere here. This is our zero. Hmm. The zero porosity lies here. Midpoint is here. So how much porosity is there? Just read this value. Half of a division. Half of a division means half of 6, 3. So we have about 3% porosity in this sandstone. And actually this is hydrocarbon bearing. This example is from Vindhyan Basin, MP, Madhya Pradesh. So I think now we can have a lunch break. Hello.
Yes, sir.
Yes, sir.
क्या आप लगता है सो गए हो?
No, sir.
तो अभी तो भूख लगाई होगी. Let's have a break for lunch, and we will be meeting around 2 o'clock. Okay.
Okay, sir.
Yes, sir.
Okay. Fine.
Okay, sir.
Good evening, everybody. My name is Satyam Kundu. I am currently professor university in applied geophysics at IIT ISM Dhanbad. Firstly, I would like to express my heartfelt gratitude to Sri Vishal Mishra sir, is President of SPG India, for providing us with this great learning opportunity. I will like to thank Dr. N.P. Singh sir, SPG training coordinator and former general manager of NGC, for arranging such an excellent online training program. I will also like to thank Dr. Sanjit Kumar Pal sir, HOD, and Dr. Anil Kumar Chaubey sir Training and Placement in Charge, Department of Applied Geophysics, IITSM Dhanbad, and other faculty members from various universities for their efforts to make this program a success. This 2 weeks long online training program comes with many informative in- aspects of seismic, well log, and other various and with others aspects of oil and gas field. Now I would like to share some thoughts of myself and my fellow batchmates regarding this online training program. ঠিক আছে হুম আর আর বলি শুনো স্কুল থেকে আসার পর ডাকবে নি আমাকে কারণ আমার হ্যাঁ ঠিক আছে ঠিক আছে হ্যাঁ 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 ঠিক আছে ঠিক আছে হ্যাঁ
राशि बची हुई है तो नहीं खाई जाएगी ਇਹਨੂੰ ਦੇ ਦੇਣਾ ਕਿ ਲੜੇਗਾ ਕੰਮ ਖਾ ਲੇਗਾ ਰੋਟੀ काम खा लेगा और रोटी अब खुद ही लाओ तो बाहर खा लेंगे करके
Yeah, I'm not right. Very difficult question. Also, 2 week training that we have been conducting for last. And then the name of the other faculty worker. So accordingly you can train your words.
Okay, fine, sir. Fine, sir. Fine. Okay.
ভাত কমা কোনো চার্জার লাইট হবে
गर्मी कर ली ना कर ली 10 सेकंड में आए कोई काम
कल आई थी काकी मेरे को बोली मैं आ रही हूँ थोड़ी देर में जो काकी को भेज दिया काकी तो काम अच्छा नहीं करती
दोपहर की सेशन नहीं कुछ
ये भी अब काम अच्छा नहीं करती तो बच्चों लोग भी ठीक मानती बाकी काम तो ये भी अच्छा नहीं करती पैसे चाहिए उधार 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 पैसे उधार जैसे मर्जी जरूर कितने
केवल बीएचपी के वर्टिकल और फ्रंट सेल पे इन जगह करेक्शन करना है
वो कह रहा मार्केटिंग अच्छा नहीं होता ठीक नहीं होता मुश्किल होती है सॉफ्टवेयर नहीं है हमारे पास आज वो आया मेरे को मैडम
उनको कंप्यूटर डाटा प्रोसेस करके दे दो करेक्शन नहीं आता लाना
वो हमारे प्रोफेसर को क्या
बड़े मजे से
मतलब जो प्रोफेसर भी तो और वो है मेरे को मैडम इंडेंट साइन कर दो मैंने कहा कितना प्लान कर रहे हो जीरो ऑफसेट मैंने कहा क्यों जीरो ऑफसेट कर रहे हो तुमको यहाँ डेटा नहीं चाहिए तुम्हारा तो साइन तो यहाँ पे कंटिन्यूटी है नहीं तो तुम्हें सबका ऑफसेट लेना चाहिए मैडम वो लोग प्रोसेस नहीं कर पाता मैंने कहा प्रोसेस नहीं कर रहे हो हेडशॉट और हेडेक डेटा लेंगे, एक्वायर करेंगे, प्रोसेस करेंगे, वो एचएस की प्रॉब्लम है, हमारी नहीं, हमको ही चाहिए। Why you are thinking that way, जो प्रोसेस नहीं कर पाएंगे? हाँ? बैंक का डेटा होगा तो आज नहीं तो कल, कल नहीं तो परसों प्रोसेस हो जाएगा। फिर शर्मा देखता, मैंने कहा देखो 2 डायरेक्शन एटलीस्ट मिल जाए, तो क्या होगा कि तुम 2 डायरेक्शन दोगे, शायद उनको वहाँ पे जगह भी ना मिले करने के लिए। अरे तो वहाँ पे अभी इन्होंने 4 डायरेक्शन की थी, वहाँ पे गाड़ी सामने करने के लिए एक ही डायरेक्शन में कर पा रहे हैं। कह रहे सैम यूज है। जैसलमेर और दिखाने फोटो भेज रहे हैं कि जीप जो है ना, वो क्या कहते हैं, सैंड में घूम रहा है उसका पहिया, तो हम वाइब्रेटर कैसे लेके जाएंगे? जीप का पहिया घुमा के फोटो वीडियो बनाने भेजी। जीप का पहिया देखो, अरे संगीता के बोले देखो मैडम ये तो जीप भी नहीं जा पाएगी, वाइब्रेटर कैसे जाएंगे? मैंने कहा अभी तो टायर भी आ गए मुझे, मैं फिर महाराज सिंह का फोन आता, मैंने बोला न्यूज़ 360 डेटा दिया तुमको प्रोसेस करने के लिए, मैंने वो लाइसेंस नहीं मिल रहा है, कैसे करें? आप हमसे डेप्थ करवा लो, डेप्थ में करा लो, कोई डेप्थ कन्वर्जन करा लो डेटा का टाइम से डेप्थ में। बीएसपी प्रोसेस नहीं करा, बीएसपी प्रोसेस करने से पहले तो बाद में पूछा आपने, हाँ प्रॉब्लम होती है, मैंने सीजीएस को बोला इतना पैसा खर्च करते हैं बीएसपी एक्वायर करने के लिए, सॉफ्टवेयर भी तो खरीदना चाहिए। नहीं डिबेटेड कर तो 0 अफसर को कर देंगे। होगा प्रॉब्लम क्योंकि आपका बैल में 17 डिग्री का एंगल ऐसे जा रहा है आपका, एजीमुथ तो ज्यादा, एजीमुथ तो है आपको एंगल 17 डिग्री है, एजीमुथ क्या है पता नहीं। एजीमुथ you have to compute in with respect to direction of object, वही एजीमुथ हुआ ना, एक एजीमुथ वेल 17 डिग्री इधर भी हो सकता है, इधर भी हो सकता है, वही तो डायरेक्शन हुआ ना, किस तरफ जा रहा है, सब सब कितना वेल इतना है, वेल ऑफसेट चढ़ा इतना, तो वो दा जेड़ा करेक्शन है वो अलग लगेगा, वेल भी इधर है, वेल भी इधर है, ऑफसेट भी इधर है, करेक्शन अलग लगेगा। चलो एजीमुथ और डेविएशन तो हमारे पास रहता ही है, हमें जो वैल्यू उसमें क्या दिक्कत है, करेक्टली अवेलेबल करना। मैंने जब आपसे बेस में करा दी बोलोगे क्या? यहाँ पे बेल आपको बहुत ज्यादा वो ज्यादा इतना इम्पोर्टेंट नहीं है, अगर बेल डेंसिटी ऑलरेडी है फिर कोई फायदा नहीं, बेल डेंसिटी इसी पास में नहीं है, 1-2 किलोमीटर तो बेल नहीं, हाँ वो तो डीपर डेप्थ के ना शैलो पे तो होंगे। म्हणजे की मात्र दिवसाचं स्टार्टिंग में बोला मैडम वो लोग कर नहीं पाता है वो मैंने है ना उनसे पता दैट इज नॉट योर हेडेक दैट इज देयर हेडेक मैंने कहा तुम तो अपनी तरफ से दो जब हमारे फिंगर फोन आता है मैडम वो तो यस तो प्रोसेस नहीं हो सकता तो और काम करो एक्चुअली जैसे मैंने नहीं बोला कि सारा काम ज़्यादा काम आज से शुरू तो जो भी कम मिल जाए प्रॉब्लम ये है करनी पड़ेगी हमारा प्रोजेक्ट तो सेकेंड हाफ में शुरू हो रहा था प्रोसेस कर करेंगे हम सेकेंड हाफ में उसको लेंगे बाकी जो वर्क हम कम है दूसरा भी आज ना ऑफिस में साथी के साथ हो रहा है तो अगर मैं ना तो आएगा लेकिन मैच का प्रॉब्लम क्या है ना 7 बजे बोलते हो 7:30 आता है हाँ तो मैं एक बार करा के कुछ रोकना
हाँ
तो कालरा को पूछा रिटर्न से शाम को फोन नहीं उठाएगा लेकिन कल भेजे तो अच्छा है ना
नमस्कार जी, नमस्कार जी, कैसे हैं? अच्छा, हम लोग का आईटी का कुछ करेंगे? हमको भेजे क्या, आपको भेजे बताइए। अच्छा, इनकम का सोर्स और क्या बताया आपने?
एक लाइन का लाइन हेलो गुड आफ्टरनून नवेश एक हम लोगों का तो एक सैलरी हो गया मेरा है ना? हाँ, और एक 70,000 के आपको क्या
Yes, sir. Sir, cell zone. Sand. Sir, it's also cell zone. Sir, it's again cell zone. Sandstone. Sir, it's again cell zone.
Order. such sandstone? Water. Yes, sir. Oil. Say gas. Okay. হ্যাঁ বল, দাঁড়া একবারে দাঁড়া একবারে দাঁড়া। হ্যাঁ বল। ওরা এখন পর্যন্ত কেউই হাত দেয়নি। কি ওটা? ডক্টর নাগারাজু? হ্যাঁ উনি দিয়েছেন। হ্যাঁ ওই দিনের লেকচার টোটাল সেডিমেন্টারি বেসিনে। আচ্ছা আচ্ছা। নাগারাজু স্যারের কোন কোন দিনের লেকচারটা বলতো? 8-এর লেকচার 1টা নাগারাজু স্যার নিচে। টপিকটা কী ছিল? হ্যাঁ হ্যাঁ, সেকেন্ড টপিক একটা স্যারের সেডিমেন্টারি বেসিনের উপরে একটা আছে, ওই দিনেই আশা করি। সেডিমেন্টারি বেসিনটা পড়িছে ওই, ওটা কি? আচ্ছা, তাহলে ওইটা তুই লিখে নিয়েছিস? আচ্ছা ঠিক আছে। আর ওই দিনের লেকচার টুটা তাহলে কী আছে? আমি তো ভাবছিলাম ওটা লেকচার টু। আমি ভাবছিলাম যে ওই তুই যেটা করছিস ওটা হচ্ছে ওটা লেকচার, মানে আমি বললাম লেকচার 1 টা অন্য কিছু আছে, লেকচার 2টা এটা আছে নাগারাজু স্যারের। ভাই তুই এটা কি বলছিস? এখন যা চলছে অশোক কুমার সে একদিনে আর 7 ঘন্টা করে লেকচার দিচ্ছে ওই লোক। হ্যাঁ মানে হ্যাঁ মানে 5 থেকে 6 ঘন্টা তো আরামসেই। মানে মাঝখানে ব্রেক আছে, মাঝখানে অল্প অল্প করে ব্রেক আছে, একটা লাঞ্চ ব্রেক আছে। কিসে না, অনেকেই অ্যাটেন্ড করেছে টুকটাক করে। আরে নবীন অ্যাটেন্ড করে নি, নবীন সেই রেকর্ডে বসে ছেড়ে দেয়, কিছু কিছু অ্যাটেন্ড করে, কিছু কিছু করে নি। হুম হুম। কিছু আজকে আশা করি। আমি মোটামুটি এই লাস্টের দিকে আমি তিনটা দিনের মানে ডে 9, ডে 10, ডে 11, এই 3টা দিন আমি একসাথে করার চেষ্টা করছি। তো ওটা আমি একসাথে মোটামুটি একটা শর্টে একটা রাফ একটা লিখে রেখেছি। এবারে মাঝখানে এটা ক্লাসটা শেষ হলে তোর হচ্ছে একবার ওই যে ভিডিওটা আছে ভিডিওটা একবার চেক করে আরও একটু ভালো করে লিখে নেবো, স্কিপ করে করে চেক করবো টপিকগুলো। হুম, ঠিক আছে, রাখলাম তাহলে। তো তাহলে লেকচারটা শর্ট করছি, একটা লেকচার একদিনের লেকচার নেই মনে হচ্ছে। হ্যাঁ, 8 নম্বর দিন বলতে কোন দিনটা? ওই লোকের যেদিন স্টার্ট হলো তার আগের দিন কি, মানে যেদিন? কিন্তু অশোক কুমার স্যারের আগের দিন ওপর দিয়ে হলে তো ডে 9 পর্যন্ত হওয়া উচিত। আচ্ছা, ওখানে তুই ডেট বলতে কি তুই সানডেটাকে কাউন্ট করিস নি? আচ্ছা, সানডেটাকে কাউন্ট না করে তোর ডে 8 পর্যন্ত। আচ্ছা ঠিক আছে, তাহলে ঠিক আছে, কারণ সানডেটাকে তোর যে শিডিউলটাই তোর ডে 7 ধরা আছে, ডে 7 হলিডে। মানে তোর এই শিডিউলটা হিসাবে যেটা ডে 9 সেটা হচ্ছে আমাদের ওখানে ডে 8। আচ্ছা আচ্ছা, বাকি ভাই আমি তো এখানে ক্লাসে বসে আছি, আমি তো ইয়াটা লিখছিলাম, ওই লোকটা লিখছিলাম, প্রিয়াংশু তো ওই ডে 8-এর তোর মনে হয় ফার্স্ট পার্টটা লিখছিল। না না না, ওকে ও শুধু 8টা নিয়েছিল, 8-এর ফার্স্ট পার্ট। 1 2 3টা তোর একটুকু লেখা আছে, অরিজিৎ লিখছো ওটা 3 নম্বরটা। আর আমি অর্পণ তোর হচ্ছে যে ডাক্তার দেখাতে গেছে। রাত পর্যন্ত আশা করি সময় পেয়ে যাবো, কারণ তো হচ্ছে তোর 7 পর্যন্ত কিছু বলা নেই। আর আমাকে এদিকে ক্লাসটা অ্যাটেন্ড করতে হচ্ছে মাঝখানে, বাধ্য হয়ে আমাকে এদিকে মাঝখানে ক্লাসটা অ্যাটেন্ড করতে হচ্ছে। সে ঘুরতে গেছিস কী করে সময় পাবি? মাংস কিনতে গেছিলি কোথায়? ইয়াতে করে অঙ্কিত? ভালো ভালো। এই তো এই হচ্ছে কাজের ছেলে। আচ্ছা আচ্ছা, তাহলে কটার দিকে বাস থাকবি? কটার দিকে? আচ্ছা আচ্ছা, ইয়েতে তুই ইয়ে পাবি, টিকিট তো তোমার ছবি নিয়ে রেখেছে, পিডিএফটা আছে তোর কাছে ছবি দেখেছে? না ওখানে তুই ওই টিকিটটাতে তো কনফার্ম দেখাবে না, ওটা জাস্ট ওয়েটিং লিস্টে যেটা ছিল সেটা দেখাবে। তোদের কি কনফার্ম হলো? ও আর কি চাই, এই তো 19 আর 21। আরে ভাই ভাই আমাদের পড়েছিল ভাই, প্রচুর সুবিধা ভাই। হ্যাঁ, কারণ তুই জায়গা খুবই কম পাবি, মানে তুই বসা যাবে না, তো অল টাইম শুয়ে দেখতে হবে। ল্যাপটপটা তোকে শুয়ে ব্যবহার করতে হবে, তাহলে শুয়ে নিজের উল্টে রাখে। তো তুই ভাই একটা জিনিস পাবি, দিনের বেলায় দেখবি যে সাইডের মানে তোর যেটা সাইড লোয়ারগুলো না, ওই সাইড লোয়ারগুলো দেখবি ফাঁকা থাকে অনেক সময়। তো যখন দেখবি ফাঁকা আছে তখন গিয়ে আমি বসতে পারিস, কারণ ওই আমি দেখলাম ভাই সাইড মানে লোয়ারের সরি সাইডের যে সিটগুলো আছে, সাইড আবার পরে সাইড লোয়ার, ওটাই ভাই আরামের, ওটাই তুই ভালো করে বসতে পারবি। আর এইগুলোতে তুই হচ্ছে একবার শুয়ে গেলে তুই আর উঠতে পারবি না। আরে পিডিএফ তো আছে তোর কাছে। আরে না, ওটা তোর আপডেট হয় না, মানে পিডিএফ বলতে তুই গেলে ওটাই পাবি, এখন যদি ডাউনলোড করি ওটাই দেবে। আর ওটা তো ওরকমভাবে চেক করে না ওরা, জাস্ট যে টিটি আসবে, টিটি আসে দেখবে যে কোন বোর্ডিং স্টেশনে কোন সিট নাম্বারে কার ওঠার কথা সেটা চেক করে নেবে, মিল নেবে, বাস শেষ। তোর এই ক্ষেত্রে তোর হচ্ছে তোর যে পিএনআরটাই সব কিছু। হ্যাঁ ঠিক আছে ভাই, বুঝতে পারবিনি। আরে আরে তাও ঠিক আছে, তুই ওখানে চাইলে একটু উঠে বসতে পারিস তো নাকি, একটু স্পেসটা তুই বেশি পাবি। না, আনলেস তুই সাইড পেয়েছিস, সাইড না পেলে তুই বসতে পারবি না। সাইড তো পাস নি করলি, তাহলে আর কি, ওই শুধুমাত্র সাইড লোয়ার আর সাইড আপার ওই দুটিতে তুই বসতে পারবি, কারণ ওখানে 2টি সিট রয়েছে, এখানে 3টি সিট, তাহলে জায়গাটা একদম কনজাস্টেড, তুই একবার শুয়ে গেলে আর উঠতে পারবি না। এবার টিটিকে বলেও দেখতে পারিস যে স্যার ওখানে যদি সিটটা ফাঁকা হয় তাহলে স্যার ওখানে আমাকে দিয়ে দেবেন বাই পারমিশন। যেমন রোহিতকে একদম লাস্ট দিন রাত্রেবেলায় তো আমরা ওখানে নিচে বসেছিলাম, নিচটা ফাঁকা ছিল বলে, দিয়ে একজন এলো স্যার নিচে, দিয়ে তারপর তাকে স্যার ওটা টিটি অ্যালট করতো, ওদের রোহিত বললো স্যার আমি এটা বসেছিলাম, প্রথমে জিজ্ঞেস ছিল যে তোমাদের সিট নাম্বার বলো, দিয়ে রোহিত বললো যে স্যার আমার সিট নাম্বার উপরেরটা, দিয়ে তারপর তাকে বললো ঠিক আছে তুমি এটাতেই থাকো, আর যে নতুন যে ছিল তাকে উপরেরটা দিয়ে দিল। আরে না, হিন্দিতে। 21 তারিখে, কারণ সবাই 21 তারিখে যাচ্ছে, কেউ 20 তারিখে যাচ্ছে না। হ্যাঁ আমিও তো বলছিলাম যে সিট পাবিনি 21 তারিখে, তারপর সবাই যাবে না, আরো আরো ভিড় হয়ে যাবে। তোরা তুই আর নমিন একটা কাজ করবি, গিয়ে পর প্রথমে রুমটা নিবি একটু ফাঁকা ফাঁকি দেখে, যেটা ফাঁকা পাচ্ছিস। আচ্ছা ঠিক আছে, নে রাখছি বুঝলি। হ্যাঁ পাঠিয়ে দিচ্ছি, পাঠিয়ে দিচ্ছি না। হুম ঠিক আছে।
Yes, sir. is Pritham Gundu and I am currently pursuing MSc at the Department of Applied Geophysics, IIT Dhanbad. Firstly, I would like to express my heartfelt gratitude to Sri Vishal Sastry sir, President of SPG India, for providing us with this valuable learning opportunity. Then I want to thank Dr. N.P. Singh sir, SPG Training Coordinator and former General Manager of ONGC, for organizing such a excellent online training program. I will also like to thank Dr. Sanjit Kumar Pal sir, HOD, and Dr. Anil Kumar Chaubey sir, Training and Placement in Charge, Department of Applied Geophysics, IIT Dhanbad, and the faculty members from several other universities for their efforts in making this program a success. This 2-week-long program has been very informative, covering various topics of seismic, well log, and other aspects of oil and gas industry. I would now like to share some thoughts from myself and my fellow batchmates regarding this online training. We have previously studied seismic data acquisition in our last semester. In spite of that, we were able to learn various new aspects of land data acquisition and marine data acquisition. Topics like data processing, seismic data interpretation and analysis, inversion, reservoir estimation, etc. are relatively new concepts to us, but we were able to grasp on these topics thanks to the excellent teachings of the faculties on this training program. That teaching will benefit us as we are about to study these topics in our upcoming semesters. The session on the application of data analytics, artificial intelligence and machine learning in the oil and gas field was a topic of interest for most of us, as AI/ML and data analytics are hot topic nowadays. Apart from the core geophysical topics like techno-economic of oil and gas, sedimentary basin was also covered. This training program ends with a 3-day long detailed session on well log data acquisition, interpretation and analysis of petrophysical properties. All the topics were covered in a detailed and interactive manner. I would like to express my gratitude to all the faculties for sharing their valuable knowledge and experiences with us. At the end, on behalf of our batch, I would like to make a small request to President of SPG India, Sri Vishal Sastry sir, to kindly provide us the PDF copy of the presentations of all the faculty of ONGC for the benefits of the PG students. I hope every participant of this online training will make the most out of it. Thank you, sir.
Any question, please? Everything clear?
Yes, sir.
Yes, sir.
Very good. So, I have given you an example to show how you can estimate the porosity, water saturation, hydrocarbon saturation, and the pH thickness. You can also find out the oil-water contact if present. We have seen many such examples, right? We can identify the type of hydrocarbon, whether it is oil or whether it is gas. So I think now we have good knowledge about the well log interpretation. At least we have at least some preliminary knowledge about log interpretation. If we are given a log, we can identify the porous permeable zones. We can infer the type of fluid, whether they are water bearing, whether they are hydrocarbon bearing. We can estimate porosity. We can estimate the water and hydrocarbon saturation, right? We can know if gas is present. We can find out the pH thickness. We can identify all layers, right? So it brings us to the end of this session. So if you have any questions, you can ask me because we still have some time left. You remember what was our goal? Our goal was to be well acquainted with the logs. Logs should not be strangers to us. We should be able to identify logs and analyze them, both qualitatively and quantitatively. Now, what do you feel? Have we achieved this goal or not? Very good. If the goal is achieved, then it's good. During this 3-day period, we discussed many things actually, basic concepts, starting from basic concepts, basic definitions, the different logs, different tools, their physical principles of measurement. We discussed a lot, and finally we have come to the end. I am very highly thankful to all of you for your patience and for your interest. You have been responding very well, and I think we made good use of this our time. So the session is over from my side.
Ashok sir?
हाँ डॉक्टर साहब.
Sir, it is 6:21. 621 means, okay, 1621, I mean to say 421. Okay.
Yes, yes, yes.
So, what I request you is to you please continue in the session in the sense that those from different faculty, then whoever has to join, they will join, and then we can rather you be present in the session also, because you will also listen to the comments of the students as well as their HOD means head of the department from where they are participating.
Okay, there is no problem for me. I will be happy to continue. I have
Continue in the sense that you continue to join the session, and if any student has something to ask you, they will ask you. Otherwise, in meanwhile, I can put the what is called introduction slide of Shri Shastri.
from my side, I think this session is over.
So, dear students, you have been listening to Ashok Kumarji for last 3 days continuously, and I believe you people will also be slightly, curious to know why so much time has been allotted for data logging sessions. So it is not the subject; it is the person, Ashok Kumarji, who himself is so passionate to share his knowledge, which he has acquired over more than 35 plus years of staying in oil and gas industry. So it is his passion that he wanted to share what all he know with you people. So such a long time was allotted, or rather kind of kept free for his sessions. Any comments from your side, students? Are you benefited?
Yes, sir. Of course, it was beneficial. He gave so much time to all of us. It takes so much energy to give lecture for 7 hours straight.
So those who are willing to join